In this section of the course, we'll be focused on decisions, the various kinds of ways we make decisions in our programs. So in the last section, we looked at how we repeat sections of code using the various incarnations of the for loop, and now we'll look at making decisions. And we've already done some of this. You're familiar, at least a little bit, with the if statement, but we'll spend some time going through the if-else statement in a bit more detail and see how you use Boolean expressions to test for conditions and decide what your program is going to do. We'll also look at an alternative method of making decisions called the switch statement, which is more useful and more appropriate in some cases and just makes your code more readable. And finally, we'll look at something that is specific to Go, how you make decisions with respect to channels. And we do that using the select statement. And we'll look at that at the end of this section. So let's get started. So let's get started looking at the if statement in a bit more detail. And as I said in the introduction to this section, you've already seen the if statement a few times, but I want to go through it in a bit more detail just so we're all sure how it works. So I have a new empty window in Visual Studio Code, and I'm going to open a folder by clicking on the Open Folder button. And I'll put it in my Visual Studio Code project, and I'll create a new folder called Rock, Paper, Scissors. And I'll open this, and I'll open my terminal window and type go mod init my app, as you always should, and that creates our go mod file. And now I'll create a new file called main.go. And in the course resources for this lesson, you will see a file that you can download and open up in your favorite text editor and copy the contents of that file and paste it in. And I already have it copied to my clipboard, so let's just paste it in and we'll go through what this code does. So as you can see, this is a very simple file. It is in the package main, and we have our standard imports, and then we have the constants. And I used a slightly different syntax to define a few constants here. It's been a while since we've seen constants, so just as a reminder, I put at the package level a const declaration, C-O-N-S-T, and then in parentheses surrounding the three constants that I'm going to have in this project. And they are rock, paper, and scissors. And you'll also notice that this time around I capitalized the constants. And that's kind of a convention in Go. When you have a constant, you typically type it in all uppercase letters, just so you can identify it as a constant and don't accidentally try to change it in your code. Because, as you know, constants cannot be changed by a program. Then in my main function, I seed my random package using time.now Unix nano, just so we'll have good random numbers. Then I declare a couple of variables and initialize them. Player choice is an empty string, player value is an int set to -1. And then I use my random package to generate a random number. And I see here that 3 should actually be a 2. So change that to a 2. That was a typographical error, and I apologize for it. Then, as we always do, we create a new reader variable that uses the buff.io package that allows us to read input from the keyboard. And then I call this clear screen function. And that's just something that clears the terminal window. And you can see the function right down here. And of course, depending on whether you're on Windows or Mac or Linux, you have to do it differently. And all this does is execute the command that clears the console window. So in Windows, it's CLS, and on a Mac, it's clear. And we make the decision using runtime.goos, which is a built-in constant that's available to our Go programs at runtime. So if you look at the value of runtime goos and it contains the string Windows, then I know we're running on Windows. Otherwise, you're on Linux or Mac. So we clear the screen, then we print out a message. Please enter rock, paper, or scissors. And we get the value in, looking for the return, the \n, and then we strip off the \n so we know the user has entered either rock, paper, or scissors. So this is the point where we actually want to start using some if statements. And you're familiar with this, at least in general, because we've used it a few times. So let's do it the wrong way first, and in the next lecture we'll improve this. We'll actually improve it twice. So I want to see what the user has typed in, and I want to determine if they typed in rock, that I want to set player value to the appropriate constant, rock, paper, or scissors, which is 0, 1, or 2. So we just type a simple if statement. If player choice equals or is equal to rock, then we set player value. Player value is equal to rock, the constant. And that would be 0 in this case. Now, of course, you wouldn't actually do it this way, but I want to start right from the beginnings with the if statement, so I'll copy that and paste it twice. If they entered paper, then player value is equal to the constant paper, which in this case is 1. And if they entered scissors, then the player value is equal to scissors. So the if statement is really straightforward. It is the keyword if followed by some Boolean expression. In this case, we only have one condition. In the first one, on line 35, if the player entered rock, then we set the value of player value to the constant rock, or 0. On line 39, the Boolean expression, the test we're running is if player choice is equal to paper, then player value is set to the constant paper, which is equal to 1, and similarly, scissors has the constant value of 2. Now, we're not going to finish this program this time around, but we should at least print some information out. So I will type format.println, and I'm doing that because, as you can see up on line 31, I used format print. And if I don't print a blank line, then anything I print out will appear on the same line as the question, and that's not that attractive. So we have a blank line, and now I'll just print out format.println player chose, and then we'll put in player choice, and value is, and then we'll put in player value. And on the next line, format.println computer chose, and we'll just put in the computer value, which is an integer. All right, let's try running this program. Make sure we got everything right. Go run, main.go. And it cleared the screen. Please enter rock, paper, or scissors. I'll put in paper. Player chose paper and value is 1. Computer chose 1. So in this instance, we have a tie. And in the next lecture, we'll look at a way of improving this if statement. 2 ways of improving this if statement. With the else clause and then with the switch statement. And we'll spend some time on that in the next lecture or 2. So we left off about here with 3 if statements from line 35 all the way down to line 45. And I suggested last time this isn't terribly efficient. And I'm going to use the debugger to show you why it's not efficient. And to do that, of course, I have to set up this application to use the debugger with the terminal app. So I'll go to my rock, paper, scissors folder, and I'll create a new folder inside of that called .vscode, exactly like this, in lowercase letters. And just like we did a few lectures ago, I'll create 2 files in here, one called launch.json and one called tasks.json. And then I'll just copy my launch and tasks from an earlier project. So I've copied it from another window, and I'll paste the tasks in. And I'll do the same thing for launch. And paste that in there. And back in my main.go, I'm going to put a breakpoint right here on line 35, okay? And I will start my debugger. So I'll start debugging, and that opens up the little debug console, and you need, of course, to click on terminal to see the input. So I'll put in rock. And you see it stops here on line 35. So it's going to do, that hasn't executed this line yet, so I'll step through this one line at a time. So it does the test there, and it says it is rock. So now I already know that I should be setting player value to rock. And yet it continues, and I'll scroll here so you can see more, to do this test. Even though we already have player value set, it's going to execute the decision on line 39. And I step again. And then it executes the decision on line 43, and then it gets to the part where it prints the information out. Okay, so I'll stop my debugger now because I don't really need to watch it print information out. But you can see the problem here, and that is that it's actually executing 3 tests when it really only needs to execute 1. And you've probably already guessed how to fix this. It's as simple as coming up here and saying else, and changing that if statement to an else if statement. And the same thing for the last one. We change this to else. Now if I put the debugger point in here again, and try running it again, let's go to the Run menu and choose Start Debugging. And I put in rock. So it's about to execute this line. Let's step through. I step through. It does that. It does the assignment. And then it immediately jumps past the rest of these else clauses. So as you can see, it's going to choose one and only one option from the else, from the list of else's. So just to be clear, if I was to do this, else if player choice is equal to rock again, and then just say format.println chose rock again, and close all these little warnings, don't show again. Let's stop this and close this. Sometimes Visual Studio Code gets a little ambitious in trying to help me. So let's stop our debugger. I'll open up the terminal window and go to the debug console, make sure everything is closed. Good. All right, let's stop debugging, and now start debugging. So I have a breakpoint on line 35, and I'm going to scroll up so you can see all of this. So I'll enter rock, and then I'll start stepping through the code. It says, okay, you entered rock. Now you might think that what's on line 41, because I have if player choice equals rock again, that will actually get executed. But it won't. As you'll see, it jumps right past everything. So the first matching, let me stop my debugger. The first matching Boolean expression from the entire if statement, which starts on line 35 and goes to line 43, as soon as it finds one that matches, it ignores everything else. Now, you can have as many else's as you want here. And I'm going to get rid of this because we don't need it. You can have as many else's as you want here, but typically if you have 3, that's fine. If you start getting beyond 3, if you have 4 or 5 or 7 choices, there's a better way to do this. And we'll go through that before too long. But right now, the important thing to bear in mind is that only one of these Boolean expressions will ever be chosen. So if none get evaluated to true, then none of them get executed. It just does the test, the test, the test, and it jumps out. So if I run this program again, let's just run it using the command line. Go run main.go. If I enter fish instead of rock, paper, or scissors, it's going to not execute any of these. Line 36 does not get executed, neither does 38, neither does 40. But it runs all 3 tests, making sure that it doesn't match any of the possible conditions we have. And because back here on line 23, player value was set to -1, here it says player chose fish and value is -1. So obviously none of these lines inside the if statement ever get executed. Only the conditions get tested. Player value never gets set to something other than its default value of -1. All right, in the next lecture, we'll look at a better way of doing this, or an alternative way might be a better way to put it, because we only have 3 choices we're testing for, plus the default condition of they didn't type the right thing in. So we're making some progress with our rock, paper, scissors game, and we're figuring out how the if-else statement works, and we'll continue with that, but I also want to introduce a new term, the switch statement. And it is simply a variation on the if-else, which is more suitable when you have many possible Boolean expressions to test. So right now, in our main function, we're creating or seeding our random number generator. We're initializing a couple of variables. We're deciding what the computer is going to choose right here on line 25. And then we're reading the input and determining what the player chose. So at this point, let's make a little variation here. Right now, we're just printing out some text at the bottom. And I'm going to get rid of that because we're going to improve upon that. So after the point where the player has made their choice, maybe we should print out what the computer has chosen. So we could do it like this. We could say if computer value is equal to 0, then we could print out what the computer chose. And then say else if computer value is equal to 1. And then again print some text here. But that's really, although that would work and we only have 3 choices, I think this is a great opportunity to introduce the switch statement. And it works like this. Switch, that's our keyword. And we're going to switch on some variable. So I'll switch on computer value. And then I have opening and closing curly braces. And inside of that, we simply put all of the possible cases. And you use the word case for each one. So we'll say case rock. In other words, if computer value is equal to rock, do what comes after the colon. And all I'm going to do here is say format.println computer chose rock, like that. And then I'm finished with that. So I want to get out of this switch statement. So I type break, and that gets us out of there, and there's no semicolon. I type that by reflex sometimes because other programming languages require the semicolon. Go does not. And then we have our second case, paper. And we do the same thing. Format.println computer chose paper, followed by a break. And case scissors. Format.println computer chose scissors. And break. Now there is one more statement we could put in there. And it's called default. And it's the default case. When none of these are matched, then whatever's after the default will get executed. But there's nothing in there. I mean, there's no situation where we're ever going to have anything other than these 3 cases. Nevertheless, it's good practice to leave the default in there. So I'm going to. So in order to make this program compile, I still have to do something with player value. So let's print that out just for the sake of getting this program to run. Format.println player choice or player value is player value. Okay, so let's open our terminal and type go run main.go. And we'll print 2 things out. So rock, computer chose rock, player value is 0. There, that works. So that is how the switch statement works. Now, that's a simple example. Let's make it a little more complicated because we still haven't determined who won the game. So let's do that, and we'll do it with an if statement and a switch statement. So here on line 56, let's type an if statement. If player value equals computer value, then it's a draw. Format.println it's a draw. Okay? And just to make things a little nicer, I'll print a blank line here. There. But if it's not a draw, then we have to determine who wins. And here I'm going to use the switch statement again. And I will switch on player value. So, first case. Case is going to be rock. And I'll just put a break in there for now. And we'll fill in the rest of the logic in a moment. Case, I don't know why I'm typing that in uppercase. Case paper. And we'll put a break in. And our next case, case scissors. With a break. And now we'll have the default case. And again, I'm typing these semicolons because it's muscle memory. So let's get rid of those. All right. If the case is rock, if the player chose rock, let's just put a simple if statement in there because there's only 2 conditions. We can say if computer value is equal to paper, well, paper beats rock. So we'll say format.println computer wins. Otherwise, the player wins. So I'll just copy this line and paste it in here and put player wins. Now I'll copy this, because these are really simple exercises or simple decisions. So let's paste it in here, and then modify it. So, case paper. If the computer value is scissors, scissors cut paper, so the computer wins. Otherwise, the player wins. And for scissors, if the computer value is rock, rock blunts scissors, therefore this should work. Now we also have this default case. And what I'm going to put in there is simply this. Format.println invalid choice. Because if the player did not choose rock, paper, or scissors, then they must have typed in something that is not rock, paper, or scissors. All right, let's run this program and see what happens. Go run main.go, and I'll put in rock. Computer chose scissors, player wins. Rock blunt scissors. That seems right, so let's try it again. Go run main go. Please enter rock, paper, or scissors. This time I'll choose scissors. Computer chose paper. Player wins. That's two for two. I'm doing really well. One more time. Go run main go. And this time I'll choose paper. It's a draw. All right, last test, let's put in fish again, which we know is invalid. And it should print out the computer's choice and then the fact that I chose an invalid option. Computer chose rock, invalid choice. Okay, well that seems to work. So that, in a nutshell, is the switch statement. And let's look at the simple example here. You're going to switch on some value. And what I'm switching on here is the computer value, which is an integer. So I'm switching on an integer. If the integer is rock, which is the constant 0, it prints this out and then breaks. If it's paper, which is 1, then it prints this out and breaks. And then the third case is obvious. If the computer rolled a 2, then it prints out computer chose scissors and breaks. In other words, it jumps right out of the switch statement. So just as only one else condition will ever get executed in an if statement with many else's, so in this switch statement, only one case will ever get executed. Now, other programming languages handle this a little bit differently. They'll allow the switch statement to match more than one possible condition. Because there are cases where you might have, for example, if computer value is 1, then do this. Or if computer value is greater than or equal to 1, then do this. It's possible to have two cases matched. But Go is not like that. They try to make it as simple as possible, and only one case will ever get matched. And if no case gets matched, whatever it follows, the default keyword will get executed. And if you leave it empty, as I did here, then nothing happens. But down here, in this case, if the user did not type in rock or paper or scissors, then what's following the default clause actually does get executed. So right now, this game, if we run it again, only runs once. So let's type go run main.go. And no matter what I type here, if I type paper, the program terminates after telling me what happens. Now, here's your challenge, and it's a simple one. I'd like you to modify this program such that it continues to play until 3, and only exactly 3, contests have been executed. So in other words, you play the game 3 times and then it exits. So that shouldn't be terribly difficult for you. You're going to have to repeat the body of code that's in the main function 3 times exactly, and you should be able to do that without much difficulty. So give it a whirl, and I'll go through my solution in the next lecture. So how did you make out with the challenge? I'm sure it didn't take you too long to realize that this requires more than simply wrapping some lines of code in a for loop. You actually have to make changes to the places where a program makes decisions. So what I'll do first of all is show you my finished version, and then I'll take you through the source code. And my code is available for download in the course resources, as usual. So let me open a terminal window, and I'll type go run main.go. So the first thing I did is print out some instructions. Rock, paper, and scissors. Game is played for 3 rounds, and best of 3 wins the game. Good luck. Round 1. So very first thing I will enter is rock. And you can see I changed it so it prints out player chose rock, computer chose scissors. Player wins. And then it prints out round 2. Now this time I'll type in fish, an invalid response. And it says player chose fish, computer chose paper, invalid choice, and then it repeats round 2, which is one of the changes you need to make. And we'll go through that in a moment. So this time I'll choose paper. And player chose paper, computer chose scissors. That makes sense because scissors cut paper, computer wins, and the final round I'll choose paper again. It's a draw. Paper again. And this time I want it player wins, and it prints out the final score. Player 2 out of 3, computer 1 out of 3, player wins the game. So how did I do that? Well, let's go through this. And the first thing you'll notice is that I've put some additional comments in my source code, and anytime I made a modification to the actual source code since the last lecture, I put 3 asterisks, just so it's easy to see what changes I made. So the first thing I did in the main function, nothing changes until line 24, where I added 2 variables to keep track of the score, player score and computer score. And then down on line 32, I simply print out the instructions using format println. So that's no big deal. Then I added the for loop on line 39. And I started with I set to the value of 1, continue while I is less than or equal to 3, and increment I by 1 each time through the loop. Then, inside that for loop, the very first thing I do is print a blank line, then print the current round. So round followed by I. So it'll be round 1, 2, or 3. And then I just underlined it to make it a little more attractive. Everything stays the same except on line 49, or line 50, you see that I moved the part where I calculate the computer's guess, or what they're choosing, from where it was much earlier in the function down to inside of the for loop. Otherwise, the computer would have the same choice for all 3 rounds, and that would get pretty tedious in a hurry. So we had to move it inside the for loop. Then one other thing I added, and I should put the comment here, reset player value to -1 if invalid choice. And this is something you would have probably encountered yourself, and if you didn't, don't feel bad because it's an easy thing to miss. If I actually choose fish and go through the if statement from lines 52 all the way down to here, as it was before, then the player value would actually remain what it was the last time I made the choice. And that's no good, because I actually need to reset it to -1 to indicate that I made an invalid choice. Otherwise, the logic down here isn't going to work as it should, a little bit further down in the program. So I made that change. A little bit further on, this is simply for visual look and feel. I print out player chose and converted their choice to uppercase, just so it matches how I'm printing it for the computer's choice. No changes. Then down here, on line 82 and following, when it's a draw, I actually have to subtract 1 from I, so the loop will repeat the current round. Otherwise, we'd have a draw. It's possible to have 3 draws and nobody really wins the game. So I have to set I to equal to I -1. And I just use the shorthand on line 85, I -. Then I got a little bit fancy in here. Instead of doing everything as we did before with an if statement, I created 2 new functions. Computer score and player score are set according to computer wins, when I pass it the existing value for computer score, and player wins, and I pass it the existing value for player score. And those are very simple functions found down here. All I'm doing is printing out computer wins and returning the score +1, or printing out player wins and returning the score +1. And that's just because I don't like to repeat myself any more than I have to. So that was the only change for this part of it. But in this one, the default case in this switch statement, again, if it's an invalid choice, I want to decrement I by 1. And that's it. And then down here at the very end, all I did was print out the final score information, and with one last if statement, I determined who won the game and printed the appropriate message. And that's all there is to it. All right, let's move on to something that's a little new and a little different. We're going to go back to channels and play with something called the select statement. So it's time to look at the select statement. And the select statement is very similar to the case statement or the if statement because it allows our program to make decisions. The difference with the select statement is that it works exclusively with channels. And we haven't done a lot with channels, but we'll have a bit of a review right now. And what we're going to do first of all is create a very simple example that shows how the select statement works. And in the next lesson or two, we'll apply that to our rock, paper, scissors game. So I've created an empty project here. It has one file, main.go, plus the go.mod file, of course. And I have just a package declaration and a function. So the first thing I'm going to do, since we're going to be working with channels, is create two channels. And I'll do it at the package level. And I'll call these var chan1, and it will be equal to make chan of string, a channel that has strings in it. And I'll do the same thing with another variable, chan2, and again that will be a channel of type string. Make chan string. Okay. Now, the next thing I'm going to do is create two functions, which I'll just call task1 and task2. And they're not going to do anything exciting. They're going to pause for a second or two and then send some information to a channel. So I'll call the first one task1. And it's just a function, and all it does is wait for 1 second. So we'll use the time package, time.sleep, which is built into the standard library, and we'll sleep for 1 times time.second. So we're going to sleep for 1 second, and then we'll send some text to channel 1, chan1. And remember, we use this syntax to send information to a channel, and since this is a channel of string, I can only send it strings. Now I'll duplicate this and paste it here and call it task2, and we'll sleep for 2 seconds and send the text to chan2. Okay. So far our program's not doing anything. We have two functions and two variables and we're not doing anything with them. So in our main function, let's do something with it. So what I'll do first of all is fire off task1 and task2 as Go routines. So they're running in the background. So we do that using the Go keyword, and we just call task1. And then we'll duplicate that and fire off task2. So now we have two Go routines running in the background. And each one of those will run exactly 1 time. So we fire off Go task1, and it says wait for 1 second, so it will wait for 1 second, and then it will send information to chan1, and then it goes away because it's finished its task. So what I'm going to do down here is type a for statement. For I is assign the value of 0, I is less than 2, so I'll run exactly 2 times, and we'll increment by 1 each time through. And here's where we use the select statement, and it's very, very similar to the case statement. I'm just going to type the keyword select, and then opening and closing curly braces, and then we have cases. And my first case will be assigning to a variable called msg1. We'll assign whatever we get from chan1, and then a colon. And what I'm going to do is simply print it out. Format.println, and we'll print received, and then whatever we got, msg1. So that's our first case. I better spell received right. R-E-C-E-I-V-E-D. And now we'll have our second case. Case message2. Again, just a variable I'm declaring. And it will hold whatever we get from chan2. And we'll do the same thing. Format.println, received, and message2. And that's the entire program. So let's go through this. First of all, we have our package declaration, same as always. This is the main package. The imports, which take care of the things we're using from the standard library. We declare two variables. Both are channels of string. Then we have two functions. The first one just sleeps for 1 second, so it pauses for a second, and then sends some text to channel 1. The second one pauses for 2 seconds and sends some text to channel 2. And then in our main function, this is the entry point for our program, we start task 1 as a Go routine, so it's cheerfully running away in the background. We start task 2 as a Go routine, and then we execute what's between the opening and closing of the for loop 2 times exactly. And we say the select. All the select does is wait for information to be received by a particular channel. In this case, channel 1 for the first case, and channel 2 for the second case. So let's run our program. go run main.go. We received 1 and we received 2. Perfect. So that's how the select statement works. Now this is a very simplistic example, and what I want to do in the next lesson or two is to adapt our rock, paper, scissors game so it uses the select statement. And again, this is kind of a contrived example because you don't need to use the select statement to have rock, paper, scissors work. We already know that because we have it working. But it will give us an opportunity to apply what we know about the select statement to a more real-world scenario. So we'll get started on that in the next lecture. So as promised, let's apply some of what we've learned about the select statement to the rock, paper, scissors game. And I have that project open, and it's in exactly the same state it was the last time we worked with it. So what I'm going to do first of all is, because we're working with select, and select is actually only useful when you're working with channels, and channels are typically used to communicate between packages, I'm going to create a new package. So I'll go over to my Explorer, and I will create a new folder, and I'll call it game. And this will hold all of our game logic. And inside of that, I'll create a new file called game.go. Okay. And I'll give it its package declaration, package game. Now, what I'm going to do next is divide my editor window into 2 panes, one which will hold main.go and one which will hold game.go. And I do that by going to the View menu and choosing choosing Editor Layout, and I am going to split to the right. And that gives me a means of looking at 2 files at once, and I'll hide my Explorer so I have a little more room. So what I want to do is I'm going to, first of all, declare a function. And I'm going to call that rounds. And I'll just leave it empty for right now, okay? And inside of this rounds function, what I'm going to do at some point is use select to process input in channels. Now, the other thing I want to do is to move as much of the logic for the game out of the main file into the game package as I possibly can. And the very first thing I'm going to do there is to actually, let's move these constants. I'm not going to need them right here, and we're going to have errors for a while, but don't worry about that. So I'm going to cut them out of main, and I'll paste them into game. And that's where my constants will exist now. And in the same way, I actually don't want my reader to be right here because I'm not going to be reading anything from this package, so I'll declare a new variable up here called reader. Var reader, and it will be equal to buffio.newReader, and it will take as an argument os.stdin. Okay, now I'm going to get rid of this reader because we don't need it here at all. Now the next thing I'm going to do is declare a couple of types. In my game.go file, I'm going to create a type called game. And it's just a struct, and it's going to hold a few things. So it's going to hold, for example, 2 channels. It will hold a display channel, which I'll call display chan, and it will be a chan of string. And it will also hold a round chan, which will be a channel of ints. Okay? And underneath that, I'm going to declare another type called round. And this will hold the information for a given round. And again, it's just a struct. And it's going to have a round number, which will be an int. And it will have the player score, which again is an int. And it will have the computer score, which is an int. And then I'm going to embed this round type right into my game type. So I'll put in here round, which will be when I'm calling the member in this game struct or game type. And it's of type round. Okay. And I'll save that. So, down here in rounds, I'm going to be listening to channels to do the following things. And I'll do two possible things. One is to print information to the screen, and that will be anything pushed into the display chan. And the other one will be to keep track of the round number, because we only want to have 3 rounds. So that's what's going to happen when we use our select statement in this function called rounds. Now, the other thing I want to do is I want to tie this rounds function to my type called game. And I can do that just by saying g for a variable name, and I'm going to use a pointer to the game type. There. So why did I create a type of game that holds a type of round? Well, over here in my main function, there's a couple of things I want to do. First of all, I'm going to create two variables, which will be displayChan and randChan, or displayChan and roundChan. So I'll create one, displayChan, and that will be assigned the value of makeChan string, and also have roundChan, which will be assigned the value of makeChan int. And then I'm actually going to create a new variable called game, and I'm going to make that the type of game.game. And I'll populate that with information that I want. So the type game over in game.go, it expects to have a channel called displayChan, so I'll put in displayChan, and that will be equal to my variable I just created on line 16 called displayChan. And it also expects to have a channel of ints called roundChan. So roundChan, and again, that's the variable I just created on line 17, roundChan. And it also expects to have a type of round. So I'm going to do that by declaring what I'm populating, what member, and that will be of type game.round. And I'll simply put the information I want in that. Round number, I'll start at 0. Player score will start at 0. And computer score will start at 0. And I have to have a comma here. So now that I have this game variable, I have access to any of the functions that are tied to that type. Right now there's only one, rounds, on line 28 of game.go, but that gives me access to the information. Let's put another function in there. So we have this function I'm calling on line 37 called clear screen. I'm going to get rid of that call because I'm going to move that function in just a moment. So let's find clear screen way down here, and let's cut it out of here. Paste it over here, give it an uppercase name or letter for its function name so it's visible outside of this package, and tie it to the game type. Now I'll save this and it should do the imports for me, and it did. Good. So there's all my imports. So now this function clear screen is available to me using the variable I called up here, or that I created up here called game. So I can actually clear the screen. So I can do that just by saying game.clearScreen. And that will work just fine. So far we've declared two variables, two channels, used those in the game function in the game package, and created a variable called game. And now it has access to two functions, clear screen and rounds. We'll be using those in a moment, okay? Now rounds, as you know, over here, is actually going to run forever in the background because that's going to be where we have our select statement. So I can do this right now just to get it started. I can say for and just run forever. And over here, I can actually start that go routine by saying go game.rounds. And it runs in the background. It doesn't do anything yet, but we're going to have a select statement in there before too long. So let's keep going. Down here, do I want to seed my random function right here? Probably not, but we'll leave it there for right now. Let's just keep going and see what's going to happen here. So the next thing I do after all of this, much of which will be going away in just a few minutes, but for right now, the next thing I do is print the instructions. So let's get that out of here. We'll cut it and get rid of this comment. And let's create yet another function over here, again tied to the game type. Func has the receiver of G for pointer to type game, and we'll call this print intro. And we'll just paste the format print lines in there and save, which should do the imports for me, and it does. Okay. So far, so good. Now, do I need player score and computer score? Nope, not at all. I can get rid of those because I'm not using them at all. We're going to be storing that information in our type game, the type rounds inside of that. So back up here, we have our game type that holds a round type, and that's where we keep the player score and the computer score. So I don't need these two anymore. Let's get rid of those. And let's keep going. So far, when this program starts, and there's still errors, those will be going away in a moment. So far, when this game starts, we just create a channel, create another channel, create a game variable, start the rounds function on the games package to run in the background. We clear the screen, so now let's print the instructions. Game.printinTro. Okay, so that's good. Now, let's get rid of this entirely, these two, for the moment, and let's comment that out, because we'll be using that in a moment. And let's simplify this for loop. I'm not going to run exactly 3 times. I'm simply going to run like this, 4. And inside of this, what do I want to do? Well, the very first thing I want to do is tell the program, and I'm going to get rid of this, tell the program what round we're on. Okay, so I'm going to say game.roundChan. I'm going to pass it 1, because that's how we start. Okay, so game.roundChan is equal to 1. And then I want to wait for that to happen. So we'll say wait for a result from game.roundChan. We need to have that pause there. Otherwise, this will execute so quickly that whatever follows, this is all going to change before too long, but whatever comes after line 34 might execute before we get the response from the round channel, from roundchan. So we need to wait for that. And that's what this syntax does. It says wait for something to happen. And now I want to jump out of the loop if we're beyond round 3. So if game.round number is greater than 3, then we're done the game. So we'll just break out of the loop. Okay? Now beyond this, what do we want to do after this? Well, we actually want to play the round. And I don't want to have all this logic in here. Instead, I'm going to come back over to my game.go file, and I'll create a new function called func with the receiver g, which is a pointer to the game. So we have access to all the information in the game type we created back at our main function. And I'm going to call this play round. And it takes no parameters, but it's going to return a bool. And you'll see why in a moment. Okay? And here is where I'm going to go back up and find that thing I commented out. I'm going to cut this seeding of our random function and paste it in here. And save it so it does the imports for me, and it did. And then it's pretty much the same logic that we've used in the previous function. So if you recall, we initialize a variable called player value, and we give that the default value of -1. And then we printed out the round information, which I think I deleted a moment ago, but I remember what it was. We just go format.println to get a blank line, and format.println again, and we print out round, and then we want our round number, which now is no longer the variable I, as it was in the previous version of the program. Now it's stored in our game variable, which I have as the variable g on my receiver, under the round type, and then round number. So we print that out, and then we format.println, and we underline everything just to make it a little more attractive. Round, and then a space, and then the round number. So that should be about the right length. And then we print in our prompt. Format.print, not println. Please enter rock, paper, or scissors. And then a prompt and a space, and we print that out. Now at this point, we can start copying things from over here. So I can copy these 2 lines, or cut them, I guess. I don't need them over there anymore. Paste them in here, and scroll up a bit so we can see things a little better. And save this. And what we want to have here is player choice is assigned the value. That has to be an assign, not an equal. Okay, so now we have that. Then we strip off the carriage return. And now we calculate the computer's choice, or the computer value. Computer value, and again that will be an assign operator, rand int n3. Rand.int n3. Save that so I can get rid of this and get rid of this. And now I can copy all of this and paste it in here. Make sure it looks good. It does. delete this. Now I need this else statement here. Do I reset player value to -1 if invalid choice? Well, I don't have to because I have it up here, and this is not functioning in a loop. This code is being executed or will be executed when we copy it. So I don't think I need that anymore. I'm going to delete that. Then we want to print out the player choice. So let's do a blank line, same as we did before. I'll just copy this, or cut it, and paste it over here, and save it to format it. Now, here's where I'm going to start using my select statement. I don't want to do format print line player chose and then print out the information. Instead, I want to send that to my channel. Because if you recall, if we scroll up here, one of the things that I said I wanted to do in the rounds function, which is running in the background all the time, is to print information to the screen. And we won't do it everywhere, but we'll show you how it actually works here. So rather than doing that, I'm going to send to, from my G variable, which is I get from the receiver, it's the game type, I'm going to send to the display chan this value. And I'm going to use the format package again, but I'm going to use sprintf, which I don't think you've seen yet. And this is actually a built-in function in the format package that doesn't print things to the screen. Instead, it returns a string, which is exactly what I want it to do. So you use the same formatting as you would with the printf on the format package, and it's something like this. So I'll just put in my string, player chose, and then a placeholder, %s, and what's going in there as an argument is exactly what I have here. So I can copy that, paste it in here, and then get rid of this line entirely. So I print a blank line, and then I send to the display chan, which is a chan of type string. I send whatever sprintf on the format package returns as a string. So it will return player chose, and then whatever the player choice is. So one of rock, paper, or scissors, which they typed in right up here under player choice. So we do that. The next thing we want to do is switch on the computer value. So let's get that, cut it out of here, and we'll paste it in here. Let me hit return a couple of times and paste that information in right here. Okay, so now we have the computer value. Let's keep going. What do we do after that? Well, we make the decision. Either it's a draw or we keep going. Now, we can't do it exactly the same way here as we did in the other one, but it's pretty close. So let's copy all of this, which starts right here on line 47 in my code, all the way down to here. I'll cut that out of there, and I will paste it in here, and we need to make some changes. So to start with, we no longer have a variable I, so I can get rid of that, and instead I can say return false. And this is why we use the return function, or the return on the function up here, Boolean. We're going to return true if the round is complete, or false if the round is not complete. In this situation, the round is not complete because it's a draw, so we have to do the round over again. And again, I'm not going to use format print line here. I'm going to send my text to the display chan. So display chan gets the value of it's a draw. And I'll get rid of this line entirely. Okay? Now let's keep going. Here, I'm actually calling a function called computer wins, or player wins, or computer wins, or player wins. And that's good. I'm going to do that, but I'm going to change those functions entirely. So instead of saying, as we did over here, format print line computer wins and returning a score, I'm going to make this a function that takes no, or returns nothing. And it actually takes no arguments. It's just going to be computer wins. And I'm going to make it available to this package with the variable G. So I'll give it a receiver. And I'll do the same thing here for computer win, or for player wins. Get rid of this, and we'll create that function in a moment, so don't worry about it. G, like that. Okay? And now I'll copy these lines, not including the if statement, and replace everything except for the if statement under paper and under scissors. Now let's go create that function, computer wins and player wins. Okay, so let's save this. And down here, we'll create another function, func computer wins, and it has the receiver of G pointer to game. And we'll copy that and paste this and call this one player wins. And all we're going to do in these functions is update the computer score or the player score as appropriate and send some text to our display channel. So g.round, and this is computer wins, so computer score plus plus, add 1 to it. And then send to the display channel, display chan, is going to get the value of computer wins. And down here, for player wins, g.round.playerscore plus plus, add 1 to the player score, and g.displayChan gets sent the value of player wins. There. So back up here, in our big if statement, the last thing we have to worry about is, the last thing for this particular switch statement anyway, is the default case, where we don't want to print out invalid choice that way. Again, we'll send it to our display channel. g.displayChan gets the value of invalid choice. So we can delete that line. And we don't have an I variable. We want to return false because we need to replay this round because it's an invalid choice. Okay? Otherwise, everything is fine, so we return true. The round is over and done with. And back over here in our main function, we can delete this and all of these extra lines just to format things a little better. All we need to do at this point is to play the round. And we know that the function playRound in the game package returns a true or a false. So we can do this all in one if statement. If not game.playRound, then we say game.roundChan, we send that a value, and we're going to send it -1 because we want the round not to be incremented as it was up here. We want it to go down 1. And what we're going to do in our select statement is add whatever value is passed to that channel to the current value of the round. And again, we need to wait for that to send some information back. So game.roundChan, that pauses until this is incremented, and on we go. All right, so let's just comment this stuff out for right now, okay? Because it's going to cause some errors. Let's get rid of these two functions we're not calling anymore, computer wins. So there should be almost no errors once I save my file to clean up my imports. The only import we now have in our main package is my app game. There's nothing else being used, okay? So we'll have to fix this up in a little while, but we'll leave that for right now. At the moment, I want to go back to my game.go file in the game package, and I want to find that rounds function, which is around here somewhere, right here. And let's use our select statement here. So we want this to run forever, therefore it's on an infinite for loop. That's what we have our code inside of. And we have our select statement. And our first case is going to populate the variable round that we're creating right now. That's assigned whatever we get from g.roundChan. And then a colon. And what do we want to do here? We want to say g.round.round number, the current round, is equal to g.round. Try that again. Round number plus round. Whatever value is passed to this channel is added to the current value of round number in the type round in the type game. So if we pass a 1 to the channel, we increment our rounds by 1. If we pass a -1, as we're doing here on line 36 of main.go, then we decrement it 1, which gets it back to the previous round number. Okay? The last thing we need to do for this case is to send something to the round channel. So g.roundChan, we'll just send it 1. So that's our first case. Our second case, and this time I'll call it message, MSG, is assigned the value of whatever we get from the display channel, g.displayChan. And what do we want to do here? We just want to print it to the screen. Format.println MSG. That's it. Okay. So let's just try running this and see what happens. Apparently we have no errors right now. Things look good. We won't get our final score, but this should at least start working. So let's try running this. Go run main.go. So far so good. Round 1, we got our instructions. Then we have round 1 printed. I'll enter rock. Computer chose rock. Player chose rock. It's a draw. And we're back at round 1. So something didn't quite work there, but we're getting closer. Let's try putting in fish. Computer chose rock. Player chose fish. Invalid choice. Let's try paper. We're on round 2. Okay, so we're getting closer, but it looks like our counting of the rounds is not perfect, but we're definitely getting closer. And this lesson's getting fairly long, so I think what I'm going to do is stop this one right now, and we'll pick up exactly where we left off in the next lesson. So we've made good progress on converting our rock, paper, scissors game to use channels and the select statement. And the last time around I suggested there was a problem in keeping track of the current number for the current round. And when I reviewed the video for that lecture, I discovered no, it was doing exactly what it was supposed to, because the first round was actually a draw. Therefore, the second time we played the game, we were still in round 1. And you probably noticed that, and I didn't, and I apologize for that. So the only thing I want to do now, before I give you a challenge, is to, first of all, get rid of these comments, because I don't need those anymore. I want to implement this last bit, the final score bit. So I'll uncomment this, and that will introduce some errors, because we're referring to things that don't exist anymore. But I'll copy it, or cut it without the comments, cut it. And I will go over to game.go and create a new function with the receiver of a pointer to the game type, and I'll call it print summary. It takes no arguments, it returns nothing, and it just prints that information out. And of course we need to fix these variables because it's not player score anymore, it's g.round.playerscore, and computer score is g.round.computerscore. And we make the same substitutions here, g.round.playerscore and g.round.computerscore. And because this is an exported function, I can go back to my main.go file. And after this for loop, after we break out of it because we finished our third round, I can simply call game.printSummary. And now I should be able to run this. Go run main.go. And for round 1, I will choose rock. It's a draw, so we're still in round 1. I'll choose rock again. And this time the computer won, so I'll choose paper. And it's a draw. We're still in round 2, so I'll choose paper again. And the computer wins. I'm not doing very well, so now I'll choose scissors. It's a draw again, and I'll choose rock this time. And there we are. Final score. Maybe I should put a blank line before that, but that doesn't matter for our purposes today. Final score, I get 0, the computer gets 3, computer wins the game. So everything works as it should. Perfect. So now I'm going to give you a bit of a challenge. In the game.go file, you'll see there's a number of places where I'm still using format.println, like this, right here. And I want you to modify the program so the only place we use format.println is when you're prompting the user for entering information, right here, format.print, not println in this case. Everywhere else, I'd like you to use the channels and the select statement to print the information to the screen that way instead. Now right away you might be asking yourself, how do I do this one, format println with no arguments? Well, you'll just simply send the channel an empty string, and that should take care of it for you. So it'll take you a little while, but it shouldn't be that difficult. You should be able to make the modifications only in the game.go file. So give that a whirl, and next time around I'll show you how I did it. So how did you make out with the challenge? I suspect that once you got started you realized it was a little trickier than you might at first have thought, and that's because of the way the channels work. So all of the changes are in the game.go file, and as I did previously, every time I made a change, I actually put a comment like you see on line 43, where I actually put 3 asterisks just to indicate the kind of changes that you needed to make. And the change that probably gave you the most difficulty was actually this one. It's the part where you have to send some information back into the channel to indicate to the place in the program where you called it that the channel is finished doing what it has to do. So I added that. I just sent an empty string back to the g.displayChan, and that took care of it. So if we scroll on down to find the next places where I made the change, here in the print introduction, rather than calling format.println directly, I used format.sprintf to build a string, sent that to the display channel, and then on line 72, I wait for the channel to say you're actually done. And that's because we don't want to try using that channel before it's actually finished printing what it needs to print. And that's basically what I did pretty much everywhere else in the program. So down in the play around, I made a change here. Again, I just used format sprintf and sent the string that returns off to the display channel and waited for the channel to finish on line 84. And I did that pretty consistently throughout the entirety of this particular file. And as you can see, there's quite a few places where I have my little comments. I better put a 3rd asterisk there. But that will actually show you where I made all of my changes. And I see that I put 2 asterisks in most places, so I may as well be consistent. I'll fix that right now. So hopefully you had a similar solution, and again, if you came up with a slightly different way, that's fine, as long as you achieved the end result. But do take some time to compare my solution with your solution and determine for yourself which way you think is better. All right, it's time to move on. So we covered a fair bit of material in this section, and with the exception of the select statement, most of it should have been pretty straightforward. So we went through, first of all, the if statement, which we had seen previously, but we went through it in a little more detail and looked at the else clause. And the thing to remember is that for any if statement, in order for what immediately follows an if or an else if to execute, the entire Boolean expression must evaluate to true. And only one else condition ever gets executed. Even if one later on would also evaluate to true, only the first one gets executed. We also looked at a variation on the if statement called the switch statement. And this is useful when you might have many else clauses, and it just makes your code ever so much easier to read, and that is always a good thing. And as is the case with else's in the if, only one case in a switch statement ever gets executed. Other programming languages handle that differently, but in Go, only one will get executed. And a switch statement can have a default case, which always appears at the end of the case list, and it should. Even if it's empty, it's always good practice to put a default colon in there and just leave it empty so nothing gets executed. We also looked at the select statement, which was the most complex of the things that we looked at in this section, and that's always the case when you're working with concurrent programming. And select statements only work with channels. And it works very much like a switch statement, but it is for channels. And finally, we revised our rock, paper, scissors game to use select and channels. And just as a reminder, it's really not necessary to use the select and channels with rock, paper, scissors. It works fine as a procedural program where nothing runs concurrently, but it was a great opportunity to experiment with select and channels a little bit. So in the next section, we'll move on and we'll begin looking at how you do math in Go. And we'll do so by looking at operators. See you in the next section. So let's do some math, and don't be too concerned. If you hated math in school and you weren't very good at it, you're not going to have any difficulties this time around, because the computer does most of the math for you. We just have to figure out what syntax to use when asking our computers to perform mathematical operations. So I have an empty window in Visual Studio Code, and I'm going to open a folder, and I'll do it in my Visual Studio Code projects as usual. I'm going to call this folder Operators. And I'll open it, and then I'll open my terminal window, and as I always should, type go mod init and give this project some name. And I'll just call it my app as usual. Try that again. Go mod init my app. That's better. Okay, so I'll close my terminal window, create a new file in that folder called main.go, and make an empty Go project. Package main, and one function, the main function, which we have to have. So the first thing I'm going to do is create a variable, which I'm going to call answer. And I will assign that the value of 7 plus 3, and then times, which is not the x as it is when you're writing it on paper. It's an asterisk in the computer programming world. And then 4. And then I'll print out the answer. Format.println answer followed by a comma and then answer. Now, ask yourself, since we have the math being done here, 7 plus 3 times 4, what is the answer? Well, it depends on how you read it. If we go 7 plus 3 is 10 times 4, well, 10 times 4 is 40. Or is it 3 times 4 is 12 plus 7, which is 19? Well, the answer to that question really depends what kind of programming language you're using. In Go, as is the case in Java and C# and lots of other languages, we follow the normal order of operations, which is to say, do multiplication and division first, then do addition and subtraction. So in that case, the answer would be 19. And in fact, that is the answer in this case. But in other programming languages, like Smalltalk, for example, it would be done in the order that it's seen. And still other languages would insist that you put parentheses around things to group them together. And that's sometimes a very good idea. If we run this program right now, go run main.go, you'll see the answer is 19. But if I come down a couple of lines and then type answer again, and this time overwrite its value with a new value, and put 7 plus 3 times 4, and then print it out, format.println, answer is now answer, you'll discover that what's done in the parentheses is evaluated first, and then it's multiplied by 4. So we'll get 40. So if I go back down to my terminal window and type go run main go again, this time I get two things. The first time the math is done, it follows the order of operations, or the precedence, that's built into the Go language, and we'll be going over that in some more detail in the next lecture or two. But the second time, it says, okay, you have parentheses, therefore you want that done by itself. 7 plus 3 is evaluated to 10, and then that is multiplied by 4. So we get the answer of 40. So the key thing to remember here is that although we're not going to be doing high-level math, we do need to know the operators that are commonly used in the Go programming language, and we also need to know the precedents that those operators follow, the rules which decide what order expressions are evaluated in. So we'll go over that and some of the operators in the next couple of lessons. So let's go through some of the basic mathematical operators as they're used in Go. And I have the same project open that we worked on last time, and I'm just going to delete everything in the main function. And we're going to start with multiplication. So what I want to do is to write an expression in Go that's the equivalent of this formula. Area equals pi r, and then this should be superscripted, but it's not because I can't do that in my IDE. Pi r squared. That's the area of a circle. Well, how would I do that in Go? Well, I'll start by declaring a variable, which I'll call radius, and I'll make that equal to 12.0. And it's important that you put the 0.0 here. Otherwise, Go will assume that radius is an integer, and we won't get the answer we expect to get. We want this to be a float. So, I have that. Now, how am I going to calculate the area of a circle? Well, it's pretty easy. Area is assigned the value of, and I need to have the number pi in there. And I could type 3.141592, whatever, but that's not necessary. Go has that as a constant in the math package. So I can just type math.pi. And make sure you get pi, not phi. That's a different constant. So that will be 3.141592, and on it goes, times radius times radius. And if I print that out, format.println, area is, and then area. And if we run the program, go run main.go, you see that the area is 452.38 and then a whole bunch of numbers. And all I did there was just take the constant pi, which is built into the standard library, and you can see it's a float 3.14159 and on it goes. And then I don't know how to square a number yet, so I just multiplied radius times radius. So because there's only multiplication taking place here, it doesn't matter what order you multiply these in, you're always going to get the same number. So there's multiplication, and that's pretty straightforward. Let's try division. Now, first of all, we'll try integer division. So I'll put the word integer in here. Integer division, because integer division is different than it is when you're dividing actual float numbers. So I'll create a variable called half, and I'll assign that the value of 1, which is an integer, divided by, and we use the slash for the divided by, 2. What do you think that's going to produce? Well, let's find out. Format.println half with integer division. And then I'll just print it out, half. So what do you think that's going to produce? You know that 1 divided by 2 is 1/2, or 0.5, but we're not dividing floats, we're dividing integers. Well, let's run it and find out. Go run main.go. So we get our area, and then we have half with integer division is 0. Well, that doesn't seem terribly helpful. That's because integer division actually only works with whole numbers. If we do it this way, half float is assigned the value of 1.0 divided by 2.0, and then print that out, format.println, half float, we'll get the result we expect to get. Go run main.go. And we get half float is 0.5. So clearly, if you want accurate division or multiplication or any mathematical operation that's dealing with something other than whole numbers, you're going to have to use a float type, float 32 or float 64. And the other thing to bear in mind is you can't do math in the same expression using float 32s and float 64s. Stick with one or the other. Otherwise, you're just going to get compiler errors, and that's a bit of a problem. So let's try squaring or raising to the power, which we could have used up here on line 12, where radius squared. Now, radius times radius gives us the same number, but radius squared would have been ever so much nicer. So let's try this. I'm going to create a variable called bad3 squared. And this is not the way that you do it in Go. In some languages, you can raise something to the power of something else by doing this. 3, and then the little shift 6, or the caret, 2. And you would think, if you're coming from another programming language that does it this way, that that's how you actually raise a number. So let's print that out. Format.println bad3 squared, and then I'll just put the variable in, bad3 squared. Let's run this and see what we get. Go run main.go. So we get our area, our half with integer division, our half with float, then bad3 squared is 1. Well, that's because the caret, used as we do here on line 23, is actually the bitwise XOR operator, which we're not going to get into because we're not going to get into bitwise operations. That's really more advanced computer programming, and you're not going to run into it in your everyday programming life, so we're not going to cover those at all. The way that you actually raise something to the power, we'll just create a variable called good3 squared. The way that you raise something to the power in Go is by using the math package, which is part of the standard library, .pow for pow. And we're going to raise 3.0 because it expects to have floats, as you can see right in the preview here that Visual Studio Code gives us. It wants a float 64 and a float 64. We want 3.0 and 2.0. Let's print that out. Format.println good3 squared. And the variable, good3 squared. And I'm missing an E there. Okay, let's run that. go run main.go. And we have our areas, our halves, our bad 3 squared, and then what we expect to see. 3 raised to the power of 2 is 3 times 3, or 9. And of course, if you want to raise something to the power of, say, 7, we could say 7.0 here instead. Of course, our variable name doesn't make sense, so I'll change it back in a moment. But just to show how this works, go run main.go. 3 raised to the power of 7 is apparently 2,187. Okay, so let's close that and change this back to a 2. Now the next one, that's multiplication, that's division, and now we know how to raise things to the power. We've already done the modulus operator, but we might as well review it. The modulus operator gives us the remainder in division. So I'll create a variable called remainder and assign that the value of 50 modulus 3. And that should give me the remainder. When I divide 3 into 50, what's left over? So format.println remainder of, well, just remainder is enough. And we type in remainder. Go run main.go. That gives us a remainder of 2, which is exactly right, because 3 only goes into 50 evenly, or the closest number we can get is 48, and the remainder is 2. Just a couple of other things. Let's look at unary operators. And again, we've seen some of these. The easiest one to look at is, say, well, we'll create a variable first. X is assigned the value of 3. X++, format.println, X is now X. And you know what that does. That adds 1 to the value of X. But we'll run it anyway, just to see the 2 printed out. Go run main.go. X is now 4. Okay, so we added 1, 2, 3, we got 4. That's exactly what we're supposed to get. And we can do the same thing, x minus minus, and then x minus minus. Format.println, x is now x. And what's that going to produce? Well, x started as 3, we added 1 to it to get 4, then we subtract 1 to get 3, and we subtract 1 to get 2. So if I print that out by running the program, go run main.go, the last line should say x is now 2, and it does. Now, other programming languages, like C#, they have something like this, minus minus x, which is not exactly what you would, it's not intuitive what that does. Normally you're working with 2 variables in that situation, and that one operator affects your current variable plus the one that it's based on. And fortunately, Go doesn't have that, because whoever came up with that, I think they were just having an off day. It does make things rather confusing. One operation should not affect 2 things. You know, one obviously because the minus minus is in front of the x, and one less obviously because you don't even have the variable you're affecting in the expression. Fortunately, the authors of Go left that out entirely. One other note about unary operators. In some programming languages, let me delete this part, okay? And let me delete this part, or let me leave that alone. I'll just delete this here and leave x alone. In some programming languages, you could do this. Y is assigned the value of x++. And that would take the value of x, which is 3, add 1 to it, and assign 4 to y. But as you can see, because I have a compiler error here, you're not allowed to do that in Go. You can't at all. You know, if you want to do that for whatever reason, you would have to do it this way. Var y is equal to x, y++. And that would do the same thing. But that's a really rare operation. Normally you're not going to run into that situation too often, and it's very easy to get over it if you have to. Okay? All right, that's enough for this time. In the next lecture, we'll begin to talk about precedence in a little more detail, the order in which things are evaluated. So let's talk about precedence. And I have the same project I used in the last lecture open, and I'm just going to, the same as I did last time, clear out everything from the main function and get rid of the imports. So we're starting with an empty Go project. And let's talk about precedence. And before we do that, I want to take you to a few websites just to give you some resources to draw upon. And the links for all of these will be stored on the course resources for this lecture. So I'm going to go to my web browser. And I'm going to show you the first one. This is the Go language reference. The technical references offered by Google, or the authors of Go, and it is highly technical. And as you can see here, this is the Go programming language specification. And there's an awful lot of things here that will seem a little dense. And it is very dense documentation. And it's dense for a reason, because, it's difficult to write a programming language. And the part we're interested in are the arithmetic operators. So let's go there. And you see they list them all here. And this is good documentation, and over time, as you become more competent or more confident in your programming, you'll probably be coming back to this site an awful lot. But since we're just getting started, I have two other sites that make things a little clearer because they give examples. So the second one is this one. It's on golangprograms.com. And this gives you the operators, the ones we're concerned with, in much simpler formats. So we have the addition, the subtraction, the multiplication, the division, so on and so forth. And there are examples for all of these, okay? And the third one I want to give you is the actual precedence, which is the subject of this particular lecture. So this is on a site called tutorialspoint.com, and it's a helpful little cheat sheet that again gives you the order in which things are evaluated, and some of them you're going to ignore, like these bitwise things. We're not paying attention to those. But the most important ones are at the top, and it shows you the actual precedence along with examples. So these are good reference things you should keep bookmarked and return to if you're having difficulty figuring out how to write a particular equation in Go. So let's go back to our code. And here we're going to start with precedence. So let's write a comment, precedence. And we'll start with multiplication again. And here, I'm going to create three variables. A will be assigned the value of 12.0 times 3.0 divided by 4.0. So multiplication and division. And then I'll create a second variable called B. And it will be almost the same. It's assigned 12.0 times 3.0 in parentheses divided by 4.0. And now I'll create a C that will be equal to 12.0 times, and then in parentheses, 3.0 divided by 4.0. And I'll print this out. Format.println A, B, B, and C, C. Now what do you think the output will be when I run this program? I'll open my terminal window and we'll run it in a moment, but think about it for a moment. So in the first one, we have 12 times 3. Well, that's 36 divided by 4. So, as you probably guessed, that should be 9. But what do the parentheses do in the B and C examples? Well, let's run our program and find out. Go run main.go. And as you'll see, they all give exactly the same response. 9, 9, and 9. So because it doesn't really matter whether or not the parentheses are there, they're kind of redundant for all three of these. Now, there may be situations where you're using variable names and you want to make it abundantly clear to whoever is reading the code, and it might be you 6 months after you wrote it, what's going on in that particular mathematical equation. So there may be a good and valid reason for putting parentheses in your code, but when you're doing just multiplication and division, it really doesn't matter. They're redundant. Okay, so that's easy enough. So let's close our terminal and keep going. So now, I mentioned this last time, integer division, but let me show you an example of how this can be really unclear. So I'm going to create a variable called unclear, and it will be equal to 12, which is an integer, times, and then in parentheses, 3 divided by 4. And then I'll print it out. Format.println unclear. Just a label, and then the variable, unclear. What do you think that is going to produce? Well, 3 divided by 4 is 0.75, and 12 times 0.75 should be 9. But remember, all of these numbers, 12, 3, and 4, are actually ints. Therefore, the assignment operator assumes that this is also going to be an int, and Visual Studio Code shows me that it is an int. So when I run this program, go run main.go, what I actually get is 0. Because in integer division, the only thing that the compiler pays attention to is what's to the left of the decimal point. And for 0.75, the number that's paid attention to is 0. And anything times 0, as you know, is 0. So that's really unclear. So you got to be careful about that sort of thing. Now let's look at parentheses in some more detail. Parentheses have the highest precedence. So for example, if I write this, f is assigned the value of 12.0 divided by 3.0 divided by 4.0. This will give you exactly what you expect. And you can probably do that math in your head. So let's print it out anyway. Format.println f and f. And of course, when we run this, there are no surprises. Go run main.go. It's going to give us 1 because, as you know, 12 divided by 3 is 4, 4 divided by 4 is 1. But if I change that by saying f is now equal to 12.0 divided by, and then open parentheses, 3.0 divided by 4.0, what's that going to give me? Well, parentheses have the highest precedence. So the first thing that the compiler will do is say, are there any parentheses? Yes, 3 divided by 4. Well, that's 0.75. And then it will divide that, or divide 12 by that. So if we print out again, and I'll just copy and paste this line right here, and run the program, go run main.go, f is now 16, which makes absolute sense when you think about it, because this is evaluated to a single number first, and then 12 is divided by the result of the arithmetic inside the parentheses. Okay? Now let's do addition and subtraction, which are pretty easy. So addition and subtraction. We'll start by printing a blank line just to separate things. Format.println, just to give me a little bit of space. And now we'll say x is assigned the value of 12 plus 3 minus 4. And y is assigned the value of 12 plus 3 minus 4. But this time 12 plus 3 is in parentheses. And now we'll do a z, or z if you prefer. Z is equal to 12 plus 3 minus 4 in parentheses. And we'll print this out. Format.println x, x, y, y, and z, z. So what do you think that's going to print out? Put a space in there just to make it a little more attractive. Well, 12 plus 3 is 15, minus 4. You can probably do that. Math in your head, that's not difficult at all. Well, let's run it and find out. Go run main.go. And you get 11, 11, 11. And just as was the case with addition, with multiplication and division, here the parentheses make no difference whatsoever. But let's copy these lines, like all of them right here, and paste them down here, and change these to equal operators, so we're just overwriting the values of x, y, and z, and change this minus sign in all 3 lines to a multiply sign. Will this produce 3 identical results for x, y, and z? Probably not, because, as you know, multiplication is done first, or sorry, what's in the parentheses is done first, then multiplication and division, then addition and subtraction. So if we run this, we're going to get very different results. Go run main.go. And as you can see, we get 24 and 60, and then 24 again. So precedence actually matters, and it doesn't take long to get used to it because Go is intended to be a simple programming language, so the rules you learned about the order of operations in primary school still apply. The only difference, of course, is that if we want to use a multiplication sign, we use the asterisk instead of an X or a dot, which you use in higher math. But the order of operations is very similar to what you learned in school. So, parentheses first, then multiplication and division, and then addition and subtraction. And that will definitely give you a good start. And these resources, back in our web browser, these are something you can refer to at any time. And it will give you the full list of all the things that you need to remember about order of operations. All right, let's move on. So this time around, I'd like to explore the modulus operator in a little more detail. And right now I'm looking at the code exactly as we left it at the end of the last lesson, and as I've been doing right along, I'm going to delete everything from the main function, and also delete the import statement. And we're going to have a look at the modulus operator. Now we've seen this a few times, it's the percent symbol, but let's look at it in a little more detail. How might you use this? Well, simplest example. Let's determine if one number divides exactly into another. Does one number divide exactly into another? And we can do that by assigning two variables. X is assigned the value of 12, so I'm using the shorthand operator to assign the integer value of 12 to the variable x, and I'll do the same thing with y. Y is assigned the value of 3. Now I want to determine, does 3 divide exactly into 12? In other words, is there no remainder? So I can write a simple if statement. If x modulus y is equal exactly to 0, then format.println, and I can say y divides exactly into x. And I will just do an else statement. Else, and I'll just copy this line and modify the message. Copy, paste, does not divide exactly into x. And if we run this, you know exactly what's going to happen. So I open my terminal window, go run main.go, and it says 3 divides exactly into 12. But if I change that value of y from 3 to, say, 5, and clear the screen and run the program again, 5 does not divide exactly into 12. So that works really well, and that's really straightforward. Then you could also use this to determine whether or not a number is even or odd, and that should be really straightforward. But there are situations where you can actually do more useful things with the modulus operator. For example, let's say I'm writing a program and I want to know what next month is. Well, I can create a variable. This month is assigned the value of 4 because I'm recording this in April. So this is April. I could do something as simple as format.println the month after this month is this month plus 1. And that will work perfectly in April. So if I run this, and I'll comment this code out so it's not cluttering up the screen. If I run this, I'll clear the screen, go run main go. The month after 4 is 5, which is May. That's perfect. But what if I was recording this in December? Well, this month is 12. And if I run the program now, the month after 12 is 13. Now, the last time I checked, we only have 12 months to play with. There are times when I wish we had 13 because I'm excessively busy, but at the moment, we just have 12. So how could I fix this? Well, I could write a complex if statement, or an if statement that says something like, next month equals this month plus 1. If next month is greater than 12, then next month equals 1. Or we can use the modulus operator. So let me comment these lines out and show you how this works and how it can be generalized to any cyclical range of numbers. 1 to 12 in our case, but it could be any range we wanted. So I'll write a for statement. For, and I'll use m for month, is assigned the value of 1, which is January. And then we say m is less than or equal to 12, because we only have 12 months to play with, and increment m by 1 each time we go through the loop. And I can do this all in one line. Format.println the month after, and now we're using the variable m, which is our index for the loop, is, and now I'll put m modulus 12, which is almost right, but not quite. Let's run this and see what we get. Go run main go. The month after 1 is 1. Well, that's not right. That's the current month. But the very end, the month after 12 is 0. Because 12 divides evenly into 12, and there is no remainder, the modulus of m12 is 0. So all we have to do to make this work is add 1 here. And I'll clear the screen and run it again, and it works exactly as we hoped it would. So the modulus operator is actually pretty useful, more useful than you might at first think. And in the next lecture, we'll look at how we can use the modulus operator in our rock, paper, scissors game. Not the one that uses the select statement and channels, the one just before that. So go find that code because we'll be using it in the next lecture. So as promised, this time around we're going to modify our rock, paper, scissors game to use the modulus operator. And using the modulus operator will allow us to simplify this code and greatly reduce the number of lines we have in our program. So just as a reminder, this is not the version of the rock, paper, scissors game, the last one we worked on, that uses channels and the select statement. It's the one just before that. So if you have the wrong one open, you can either open the correct one from your local computer or go download the source code from the appropriate lecture in the earlier section. So once you have it open the main.go file. And the first thing I'm going to do is write some comments on the constant part, lines 14 to 18 in my code. And I'm going to write simply what beats what and what kind of logic we can use to make some determinations using the modulus operator. So in this case, rock, well, it beats scissors because rock's blunt scissors. And the logic I'm going to use is scissors plus 1 modulus 3. And that's going to return a value of 0. Okay? Just as explained to you how the modulus is going to be used. This is an example, and hopefully it'll make sense momentarily. And the second one, paper, well, paper, it beats rock because paper covers rock. And the logic is rock plus 1 modulus 3 is equal to 1. And finally, scissors, well, it beats paper because scissors cut paper. And the logic is paper plus 1 modulus 3 is equal to 2. Now, if you work this out, you'll see that it makes perfect sense. And if you want to verify it by hand, you can simply do some format print lines and print out this logic, and you'll see this is exactly what it returns. So for the first one, for example, rock, the logic is scissors plus 1. Well, scissors is equal to 2. 2 plus 1 is 3. 3 modulus 3 has no remainder, therefore it equals 0. And the same logic applies for the next two lines. Now, knowing this, we can come down here in our program, all the way down to the section where we make this big switch statement. And in my case, it begins on line 85. I'm going to comment everything here out, okay? Which will give us an error, but I'll fix that in a moment. And I'll come up here, and I will close the curly braces. Now, our program won't work right now, because none of this logic is being implemented. But wait to see how few lines of code are necessary using the modulus operator to make our program simpler. So the first thing I'm going to do is check for the case where the user in fact entered an invalid statement. So they put fish instead of rock, paper, or scissors, because modulus isn't going to help us at all in that case. But that's a really easy test. I can simply say else if player value equals the default value of -1, then we know they've made a mistake. So we can simply print out the message, format.println, invalid choice. And the other thing we have to do there, of course, is to decrement I, so we repeat the current round. Now we can use our modulus operator. Let me give us a few blank lines so we're not so crowded. Else if, what we're going to check here is if the player value is equal to the computer value plus 1 modulus 3, then in that case, the player won. And all we have to do is call our player score is equal to player wins and pass it player score. Exactly as we did down here. But we had to do that 1, 2, 3 times for all 3 cases, and then we had a default case. So the default case we've already handled right here in the lines where we say they have an invalid choice, but all of the other cases are being handled here. And all we have to do is to make the assumption that if the player didn't win, then it must have been the computer. Computer score is equal to computer wins and pass it computer score. And we should be able to delete all of this commented out code entirely. And look at how much shorter our program is at this point. That's far less code, which is far less opportunity for errors, which is also far less code to maintain. Now let's run it and make sure it works the way we expect. So I'll open up my terminal, go run main.go. So far so good. Round 1, I'll enter rock, and the computer won. Okay, well this time I'll put scissors. And I won. So right now it's a tie, 1-1. And let's see what happens if I put rock in again. It's a draw. Okay, I'll try rock one more time. And the player wins the game. And it works exactly as expected. And you can verify this by playing it as many times as you wish, and you will always get the correct results. Now, if you don't like the modulus operator, which is not uncommon for people that are coming to programming for the very first time, feel free to do it the other way with the switch statement or a series of if-elses, whatever you're comfortable with. But over time, you'll come to realize just how useful operators like the modulus operator can be in terms of keeping your code shorter and keeping your code more concise and less error-prone. But this is the sort of thing that people get used to over time. And if you're not comfortable with it right now, don't worry about it. Over time, it will become second nature to you. All right, that's enough for this time around. Let's move on. So this time around, I want to look at the relational and conditional operators. And we'll do so using a simple example. So I have one of my earlier projects open, and as usual, I'm just going to delete everything out of the main function, and I'll delete the import statement, and let Visual Studio Code re-add the imports as necessary. So I now have an empty main function in a Go file that just is in the package main. So what I'll do first is create a variable, which I'll call second, and I'll use the shorthand operator to give it the integer value of 31. And I'll create another variable, minute, and again I'll use the shorthand to give it the integer value of 1. And then I'll write a simple if statement. Is less than 59, and second plus 1 is greater than 59. Then I'll just add 1 to minute. And then I'll print it out. Format.println minute. So this is a really simple program, and what I want to focus on here is what's on line 9, and that's the if statement. So if we look at this, the operator with the highest precedence in this line is the plus sign. So what gets evaluated first is second plus 1. Then after that, the next in precedence is the less than sign and the greater than sign. So those get evaluated next. And finally, the logical operator AND gets operated. And it only makes sense that it happens this way. It would make no sense whatsoever to say evaluating this part first. And I'll put parentheses around it just to show you what I'm focusing on. And Visual Studio Code tells me this doesn't make any sense. And it doesn't make any sense because 59 is an integer. Second is also an integer, but this and this doesn't really evaluate to anything. So that doesn't make any sense. So if we put parentheses around the parts in the order they're being executed, according to precedence, this is first, so that gets evaluated. Then we have this getting evaluated, and this entire section getting evaluated. And finally, we would have the AND operator being evaluated. Now, those parentheses are completely redundant. What we have now is exactly what we had before I put the parentheses in. But in some cases, if you have a complex if statement, those parentheses make your code ever so much more readable. And although they are redundant, and some IDEs will actually warn you that they're redundant, sometimes they're helpful and they make your code more readable. And there is nothing to stop you from putting them in order to make your code more readable. Because anyone who's been programming for a while will tell you, you can go back and look at code you wrote 6 months ago, and unless you have detailed comments, and unless you've made the effort to make it readable, you'll have a difficult time understanding code that you yourself wrote. So sometimes the parentheses just make things a little bit more readable. Now, we've already seen the OR operator, and I could substitute the AND for an OR, and it would function exactly the same way because the AND and the OR have the same level of precedence. And what I just really want you to focus on and to pay attention to when you're writing your code is that it is extremely helpful to put things in your code, like redundant parentheses, if it's going to make it more readable for you or for someone else who has to maintain your code a little bit later on. All right, that's enough for this time. Let's move on. So this time around, I want to look at another aspect of how things are evaluated when making decisions in Go, or precedence. So I'm going to delete all of the code out of my previous project, including the import statement, and I'll let Visual Studio Code import things for me as necessary. And what I'm going to do first is declare two integer variables. A will be assigned the value of, say, 12, and B will be assigned the value of 6. And then I want to come down here below the main function, and I know there are errors there. We'll take care of those in a moment. I'm going to create a new function called divide two numbers. And it will take two arguments, x and y, both of which are integers, and it will return an int. And all I'm going to do, and this is very bad code, and we're going to fix this in a minute, is just return x divided by y. Back in my main function, I'll call that function, and I'll assign its result to a variable called c. So I'll call divide two numbers, and I'll pass it a and b. And now I'll just check to see if c is equal to 2, then I'll format.println. We found a 2. Okay, so this is really, really bad code. And I'm sure you immediately see why it's bad code. Because first of all, if A and B are set using some other logic in our program, in other words, if I'm not hard-coding those values, then there's an opportunity for error. But first of all, let's run this and make sure it does what we want. So, open my terminal, go run main.go. And it says we found a 2. And if we change this to a 0, then you'll see the problem. So let me clear the code here and run the program again and execute it, and I get a runtime error, integer divide by 0. And as we all learned back in math in school, division by 0 is something you ought not to do. It can cause very bad things to happen. I've always secretly suspected that it might open a black hole and eat the universe. But anyway, whatever the case may be, we're certainly not supposed to divide by 0. And this program doesn't actually handle that case at all. Now, we could do that. We could fix it by doing something like this. Before this call to the code, we could put an if statement. If b is not equal to 0, then, and just close the parentheses down here. And if I save this and run the code, so I'll clear the screen, go run main go, and if we did this right, nothing should happen. It should just terminate with no output whatsoever. And that's what it does. Okay, well, that's one way of handling it. But there's actually another way of handling it, and this is something called the short circuit evaluation, sometimes called McCarthy evaluation. And what I'm going to do is comment this code out and replace it with something like this. We'll say if b is not equal to 0, and then I'll just pass the actual function call as a parameter, divide two numbers, and I'll pass it, say, a and b. If that's equal to 2, then I'll say format.println found 2. Now, this might not seem immediately obvious what's going on here. And this is where short circuit evaluation or McCarthy evaluation comes into play. Because if we look at the actual precedence of what's going on here, this has the lowest precedence right now. So this will get evaluated first. And only if this is true, or this condition passes, will the second part, after the logical AND, get evaluated. So we can verify this is the case simply by running this code. So right now, A is 12, B is 0, and if this gets executed, divide two numbers, if that gets called, then we should get an error. So let's run our code. I'll clear the screen, go run main.go, and nothing happened. And that proves, beyond the shadow of a doubt, that this function never got called. So this is a really good way of handling it. Now, the thing to bear in mind is if I, say, copy this and paste this down here, and then comment this out, and change the order that things are taking place. So I'll take this and move it to the right-hand side of the expression. So what I'm doing now is calling first divide two numbers and then checking to make sure that b is not equal to 0. And if we try to run that, go run main.go, you'll see that we get the error because the short circuit evaluation always goes from left to right. So in this case, this is never going to work, and this will. So let's comment them both out right now, and look at one other way of handling this. So this lesson is mainly about short-circuit evaluation, but I said very early on that this is a singularly bad idea, this function which does no error checking whatsoever. And because I might be calling this function from anywhere, it makes sense to put the evaluation or the error checking right into the function itself. So we could do something as simple as this. Rather than having this function return an int, we could have it return two things. And I do that simply by putting two arguments in parentheses, an int and an error. Now this is a built-in type from the Go standard library that we can actually populate with an error if something goes wrong. So all I have to do to make this work is check for and generate an error if necessary with a simple if statement. If, and in this case it's y, that's what we're dividing by, if it's equal to 0, then I'll say return 0, because we have to return some kind of integer value, and also return a new error. And I do that by saying errors.new, and just write an error. And error messages in Go always start with a lowercase letter. That's the convention. So I'll just say cannot divide by 0. And then I can come back up here and make this a little bit better. I can say C, and now we check for an error, which I'll just call ERR, which is what it's usually called in Go, and then call this function. Divide two numbers, A and B. And then I check to see if there's an error. If error is not equal to nil, and it will be nil if there is no error, because I have to actually fix this function down here and say return x, y, and nil. If there's an error, then format.println error. And I can just say else. If C is equal to 2, format.println, we found 2. And I'll spell found right. All right, so let's look at this again and see what we're doing. So I'll get rid of this code because we don't need it right now, and I'll just cut it so I can paste it back in so you'll have it to refer to when I post the source code to this lesson. We declare a variable called A, we assign it the value of 12. We declare a variable called B, we assign it the value of 0. Then we call divide two numbers, passing it those two integers, and getting back two values, C, the result of the division, and error, which will be populated if there is an error, and the only error we're checking for is division by 0, or it will be nil if there is no error. So the if statement immediately following it, if there's an error, just print the error message out, and then nothing else executes, so we're finished. If there is no error, then we check to see if there's a 2. If the result is 2, we print that out, otherwise we do nothing. So let's run this program and see how it works. Go run main.go, and I should see an error message. Cannot divide by 0. Perfect. Okay. So that worked. Now if we change this back to, say, 6, and run the program again, it works as expected. All right, so the short circuit or McCarthy evaluation is extremely helpful. The thing to remember is that it always runs in Go from left to right, okay? And also when you're writing functions that potentially could generate an error, often the functionality you're implementing in the function might automatically generate an error, but sometimes you have to do it manually. And we did exactly that on line 25 of this program. Okay, let's move on and finish off our consideration of operators. So the last thing I want to go over in this section is the assignment operator. And we've already seen a few uses of the assignment operator, but it's worth going over again, and it's worth pointing out all the ones that are available to you. So I have the project that I had open last time, still open, and as usual, I will delete everything in the main function, delete this function we're not going to use, and delete the imports. And we'll start right from scratch. So we have an empty Go project that has one file with just a package declaration and an empty main function. So let's first of all create a variable. We'll call it x. X is assigned the value of 12. So x is an integer value, and it has the value of 12. And we've already seen this one, x++. And if I go format.println, you know exactly what that's going to do. And print out x, If we run this program, it will add 1 to x and print out 13. Go run main.go. And there's 13. And if we change that to a minus minus, that will again, and I'll clear the screen, go run main go, that'll print out x minus 1. Perfect. Now, there are other ones available to you. For example, if I just say leave these lines here and create a new variable, y, and assign that the value of, say, 10, and I go y times equals 2. You know what that's going to do as well. You can guess. Format.println y. So first it'll print out the value of x, then it will print out y times 2. And that makes it 20. And not surprisingly, if I change this to a y divided by 2, so y divide equals 2, that will change the value of y to 5. So it divides by 2. So those are the ones that you need to be aware of, and you'll see them used quite frequently. Now, in other programming languages, the assignment operators like the ones we're using here have an unintended side effect. For example, in Java, for example, if you try to do something like this, and I'll use Go syntax to try to implement what you might do in Java, and you'll see why it doesn't work and why that's a good thing. If I assign, say, z is assigned the value of y minus equals 8, I get an error. Go will not let me do that. And that's because the authors of Go said, no, the way that this is handled, the way the assignment operators are handled in other languages, has an unintended side effect. In Java, if you did something like this, and this is not Java syntax, just to be clear, it would actually assign the value of this calculation to z, and it would change the value of y. And the Go author said, that's a bad idea, so let's just not do that. So you can't do that in Go, and that's actually a good thing. So that's our overview of the assignment operators, and some of them you had seen before and some of them you had not seen before, but it's useful to understand how they all work, and it's critical to understand how precedence works. So let's move on to the next section. So in this section of the course, we're going to be talking about strings a great deal. Now, we've been working with strings right along, but we really haven't explored the various kinds of things you can do with them. And I'm going to start with an exploration of what a string is. So I have Visual Studio Code open, and I'm going to create a new folder. So I'll choose Open Folder, go to Visual Studio Code Projects, and create a new folder called What is a String? And I'll save it. And I'll open this, and open my terminal, go mod init, and I'll call it my app again. And close this terminal, and create a new file called main.go, as usual. And I'll give it its package declaration, main, and create an empty main function. Okay, so we're going to start by exploring exactly what a string is. And I'm going to do that, first of all, by printing a blank line, just to keep things clear. So I'll use my format package, print line with no arguments, and that will print a blank line to the terminal. Now I'll create a new variable called name. I can call it whatever I want, but I'm just calling it name. And as usual, I'll just put some text in here. Say hello world. Now, we've been doing this right along. Format.println, and we just print, say, string, and then name. And that does exactly what you'd expect. So if I run this, go run main.go, it prints out string : hello world. Perfect. So no surprises there. Now I'm going to copy format println, because I'll be using this a fair bit this lecture. And I'll paste that in there. Now, I'm going to format println, and I'm going to say what comes after this are bytes, because a string is really a collection of bytes, a slice of bytes to be more accurate. So if I go over this, if I say for I has the index of 0, and I is less than, and this is a function we saw a long time ago, len, it just gives me the length of a slice or other elements that can be counted, and I put in name, and I++, and iterate over the entire string hello space world, and then I say format.println, and I want to print out what the byte actually is. So I'll put %x as a placeholder, This should be format printf, I'm sorry. And then name index I. So what I'm doing is printing out the byte value of the actual letter or the byte in the slice of bytes that makes up a string. So if I run this, for example, go run main.go, we get first of all our string hello world, then a blank line, then the label bytes, then it prints out the bytes. Now those are all together and very hard to read, so let's put a space between them, just like this. And clear the screen and run it again. And there are the various bytes that make up hello world. Now after this, I'm going to print 2 blank lines just to get a space in there. And now let's print out the information in a slightly different way. So I'll say, for a label, just so we know what we're looking at when I run this, format.println, index, and then a tab character, which is the \t, then rune, and then a tab character, and then string value. I'm going to go through the entire name, which is a slice of bytes, once again. For x, y is assigned the value of range name. Just a different way of going over that slice of bytes. And this time I'll print out format.println x, which is our index, and then a tab character, and then y, and then another tab character. And this time I'll print out the string value of y. And after that, I'll have a blank line again. So I'll just put that in there now before I forget. So let's run this, clear the screen, go run main go, and we get hello world, then we get the bytes, then we get a table, sort of kind of a table, that shows me the index, which is what I'm counting by. So the first index would be the letter H in our string hello world that's stored in the variable name, an uppercase H, which apparently has a rune value of 72 and a string value of H. And if you look at the line just above that under bytes, it has the byte value of 48. So you can see hello world printed down in the rightmost column. Now, when I say that the value of a string is actually a slice of bytes, we also call it a slice of runes. And a rune is nothing more than an integer, a 32-bit integer. So the nice thing about runes is that it's not just the Roman alphabet, A to Z, and the numbers 0 through 9 and so forth. You can actually put any kind of value you want in the rune because it's stored as a Unicode value. Now, I have a link on the course resources for this lecture that points to a web page on Wikipedia. And I'm going to show that to you right now. So let me go to my browser. There it is. And if you're interested in reading about Unicode, here's all the information you will ever need to know about Unicode characters. And the great thing about them is you can store more than just Roman characters. You can store Japanese characters, or, as I'm about to, Greek characters. So I'm going to go to Google Translate, and I'm going to type in the text, hello world, like that. Actually, I'll make it exactly the same as the other one, so I'll get rid of the punctuation. Hello world. And this gives me the Greek equivalent of hello world. So I'm going to copy that and go back to my IDE. And I'll take this entire section and duplicate it. And down here, just before I do the same code over again, I'm going to reassign the value of name, and I'll make it equal to those Greek characters. Okay? So now, when I clear the screen and run the program again, it runs, but the first time through it prints all the things we saw last time, hello world down here. But the second time through, because these are Unicode characters, which are integer 32s, and also known as the rune in the Go programming language, we can store any kind of character that's available to us in the Unicode standard in that. And that's extremely helpful when you're dealing with, say, internationalized programs. Now, we've already looked at how you join strings together, but I want to go through this again and show you a new way of doing it as well. So this time I will again print a blank line. So I'll copy my format print line and paste this in here. And now I'll put a label out. So format print line, 3 ways to concatenate strings. Three ways to join strings together. So we're going to join some strings together. Let's create some variables, and I'll call one H for hello, because I'm going to put the word hello in there with a comma this time, and a space. And then W will be assigned the value of world, period, like that. So three ways to concatenate or join together strings. So we've already seen this one. My string is assigned the value of H plus W, make that a W, and then format.println my string. So if we run this right now, let me scroll this up a bit to give us more room. Go run main.go. The last thing printed out should be hello world. And it is. So that's one way to join strings, but it's not terribly efficient. The compiler does it best it can with that, but as we said a while ago, strings are actually immutable. And joining them together, although it's really easy to use that plus sign, there are better ways of doing it. And we saw this one as well. So using FMT. So my string now has the value of format.sprintf, and then our placeholder text, which is in double quotes, %s, %s, I'm going to put two strings in there. And for the first one, I substitute H, and for the second one, I substitute W. Okay, so let me get that blank line I've been promising to use throughout this just to keep things clear. And I'll put a blank line right after I printed the first way using the plus sign. And then I'll put one after this one as well, just to keep things clear. So if we run this again, we get exactly the same output for the last two things. And of course, I actually need to write this to the screen. So format.println my string. And if we run this again, the last two lines will be identical. Go run main.go. So we have hello world and hello world. And the only difference between these two is that using the format package, and we used the method sprintf, which returns a string and stored that value in the variable myString, the sprintf and the various incarnations of it, where we're using placeholders, is actually far more efficient. It's a far more efficient way to combine strings than what we've just been using with the plus sign right up above. So the third way is one you haven't seen yet, and it's using String Builder, which is available to us in the strings package. So the first thing I'll do is create a variable called SB for String Builder, and it is actually from the strings package, which is built into the standard library, .builder, right there. So that's a variable. And what I'm going to do to this is call some built-in methods. And we'll be seeing more of the methods available to us as time goes on. But right now, we'll just use two. We just use one, really. SB.writeString H. So SB is a string builder. And I called the function or the method writeString that's built into String Builder and said append to whatever you currently have the value of H. And H is hello, comma, space. And then I'll do exactly the same thing, sb.writeString, and put in W, which is world, period. And then to execute that, I can just say format.println and call another function built into the string builder, sb.string. And when I run this, I should get 3 hello worlds at the end of my program. Go, run, main, go, at the end of my output. Hello world, hello world, hello world. So you might be asking yourself, why on earth are there 3 ways to do precisely the same thing? Well, in part, it's because the authors of Go know that their programmers, that the people using this language, expect to be able to join strings using something like a plus. It's a plus in this language, it's a dot in PHP, it's a plus in Java. So they expected that to be available. So it's the simple operator we've seen before, but instead of performing addition, it actually joins 2 strings together. But it's not very efficient. So using plus, not very efficient. Using format is more efficient. And using String Builder is very efficient and actually gives us more control, which we'll be seeing when we look at the String Builder in a bit more detail later on in this section. So there's 3 ways to join strings together. Now let's put in another blank line, format.println. And the last thing I want to do is to say, get a substring, to get a range of characters from within a particular string. So just to be sure I know what's in my name variable, I'm going to overwrite that. Name is equal to A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z, or Z if you prefer. So that's what's in my name variable right now, the uppercase alphabet, using the Roman alphabet. And what I'm going to do now is print out a substring. So I'll say format.println, and I'm actually getting a substring, or a range of characters from the slice of bytes that makes up this string. And I do that really easily. Format.println, the name of the variable, which is name, and I'm going to start counting at the first position, which is 0, and I'm going to get exactly 13 characters. Okay? So it'll get me from A to the 13th character in the alphabet, or halfway through. So when I run the program this time, go run main.go, I get A through M. And if I change that index, don't start at 0, instead start at, say, 10, and run it. I'll clear the screen, go run main go. The output is different. I get K, L, and M. So I'm starting at the 0th position in the first instance, but I'm starting at the 10th position in the second instance and going to the 13th position. So that gives me K, L, and M, which might seem like an unusual way to count, but this is the way that slices are treated in Go. And it doesn't matter what kind of slice you're dealing with. If you want to get a subset of that slice, this is the syntax you will use. All right, that's enough for this time. We'll move on with some more information about strings in the next lecture. So in this lecture, I want to talk about indexing. And if there is anything that causes a little bit of pain and suffering and confusion among, for example, first-year computer science students, it's the way that we count certain things in programming or in computer science. So I'm looking right now at the project as I left it last time around, and as usual, I'll delete these import statements, and I'll simply empty out the main function entirely, just so we're starting from scratch. And the first thing I'm going to do is declare a variable. And I'm going to call that course name, which is the name of this course. And it will be Learn Go for Beginners Crash Course. Okay? And right above that, I'm going to paste in some comments that I wrote before this lecture started. And we'll get back to those in a moment. Okay? And the first thing I'll do after I've declared that variable is to simply print out some information, just so I can use that variable and I can run this program. So I'll use the format package, format.println, and I'm going to print not course name by itself, but I'm going to use those square brackets like we did in the last lecture and like we did when we talked about arrays and slices. And that's why indexing is so important, because while we use indexing in strings, and we're going to do so repeatedly for this section of the course, we also use the same method of counting things or referring to elements for arrays, for slices, and for other things in Go as well. So it's pretty important, and we need to get used to it. So what I'm going to do in this line, line 11, is print out course name index 0. And you should already know what's going to happen when I run this program. So if you look at the comments above course name, you'll see that I have 0 to 9, 0 to 9, 0 to 9, and 0 to 1, 2, 3, 4 over top of each letter in course name. And then I have the tens counting in the line just above that. So using that as a reference, if we wanted to get the C in course at the very end of the string, that would be 29. Now, if I run this program right now, since I'm looking at position 0, is it going to print out the letter L? I'll run it in a moment, but before I do that, ask yourself, what is the output going to be? So I open the terminal and I write go run main.go, and as you'll recall, it's not going to print out the uppercase L, it's going to print out 76, the int value, the int 32 value, or the rune that corresponds to the uppercase L. So to make that print as a string, I have to cast this, or convert it, we actually use the word cast in programming, to a string. And now it will print out the uppercase L. And it does. Okay. So I've done that. Let's see, I want to print out the uppercase G in Go. How would I do that? Well, I duplicate this line. And again, I'll go back up and look at my little helper here, the uppercase G in Go, is a 6. So I print that out as 6. It's the 7th position, but index 6, because we start counting at 0. And we actually do that in the real world as well. For example, here in Canada, and in the States, at least every state I've been to, and I've been to 48 of 50 of them, if you're in an office building or a hotel, if you're on the ground floor, that's called the ground floor, which is actually the 0th floor, because the next floor up, if you go up one flight of stairs or get in the elevator and hit the button just above G, it's always labeled 2, at least in this part of the world. So we actually count that way sometimes in the real world. Anyway, let's go on here. What I want to do next is write a for loop. So I'll write this for loop. For I is assign the value of 0, and I is less than or equal to 21, and I++. So there's my for loop. And inside of here, I'll say format.print, not print line, but print, and then I'll cast the current index of course name, position I. I'll print that out. So what do you think that's going to print? Well, looking at our index, we're starting at position 0. So the first time through this loop, it will look at course name, find what's in position 0, convert it to a string, and print it out. And of course, that's L. And it will do that up to and including position 21. And if we look up here, 21 is position S. So it should say Learn Go for Beginners. So let's run it. There's my L, my G, and Learn Go for Beginners. So that works really well. But what if I wanted to print, say, just one word? Well, let me copy this entire thing, and let me do a format.print line here to get a blank line. And I'll copy this whole thing and paste it here. And now I'll start at, say, position 13, which is 10, 11, 12, 13, and I'll go to position 21, which is the end of the word beginners. Leave it there as it is. So if I run this now, go run main go, it's printing out just the word beginners. Now this might seem a little confusing to you, and it's almost always because people who are relatively new to programming forget about starting from position 0. But after a little while of doing this and fixing the same bug over and over, eventually it becomes second nature. All right, let's move on. So we've used the len, or length function, a few times, and I want to talk more about string length and a little bit more about indexing as well. So the first thing I'll do is get rid of this part, because we don't need to print out those letters anymore. And then after that, let's print out the length of the string, and I'll get rid of this as well. So let's say format.println, and just as a reminder, length of course name is, and then len course name. And let's make that a capital N, just so it's accurate. And if I run that, no surprises at all. Go run main.go. According to the comment I have at the top, it should be 34 characters long. Is that right? Ask yourself that question. Let's run it and find out. And of course it's 35 because we start counting from 0, something that will eventually become second nature to you. So that's pretty straightforward. And of course we can also use, let me close this terminal window. We can also use index in other ways, and look at the length of things in other ways. For example, let's create a slice of strings. Var mySlice is a slice of string. And let's put a few elements in there. MySlice equals append mySlice, and I'll append 1, and then I'll duplicate that twice, and put in 2 and 3. So we can also use the length operator on this slice, which makes sense because a string, as you know, is a slice of bytes. So I can print out format.println my slice has len my slice elements. And if we run this, no surprises, go run main.go, my slice has 3 elements. And just like I can refer to an element in a string by its position, I can also refer to an element in a slice by its position. So I can say format.println the last element in my slice is, and then print out my slice, Now I could, if I wanted to, put a 2 in there, but I can also use the length function here. Len mySlice, and I can't do that. That won't work. We could try it. Go run main.go. We'll get an error, and the error is index out of range 3 with length 3, because we start counting from 0, which is why I keep stressing this. So we actually have to put length of mySlice minus 1. And if I run it this time, go run main.go, it'll work as expected. The last element in mySlice is 3. Now, if you go back to the ELIZA code, I'm going to bring it up right now, and look in the doctor.go file, at line 148, you'll see we're doing exactly that sort of thing. So we loop through the matches list. Now in this case, matches is actually a slice of strings, just like mySlice was. And my for loop says for I is equal to 0, or I is assigned the value of 0, I is less than the length of matches. We don't have to use a minus 1 there because we're using the less than operator, not the less than or equal to operator, but we're doing exactly that sort of thing in the doctor.go file in the ELIZA project. So the first time through, I go through and I say what's in matches, index I, and I starts at 0. So you can see that we're going to be using this means of counting from 0 or indexing, and the length of a string or the length of a slice of strings or the length of anything that can be counted quite a bit in the Go programming language. All right, let's move on. Anytime you're working with strings in Go, it's often useful to be able to determine whether or not a given string contains a certain character or a certain range of characters, and then to figure out where in that string those characters exist. So I'm looking at the same code I was looking at last time, and as usual, I will delete everything inside the main function and start from scratch. So this time around, I'm going to create a slice of strings called courses. So courses is a slice of string, and I'll populate that with some information to start with. So well, the first entry will be the name of this course, Learn Go for Beginners Crash Course. And then I'll duplicate that 3 times. 1, 2, 3, and just change the name of the programming language to Java, and then Python, and then C. And now I'll range through this slice of strings. For, ignore the index, the current iteration will be called x, is assigned the value of range courses. And now I want to determine whether or not the characters uppercase G, lowercase o, the word go with a capital G, exists in each of these entries. So I can do that using the strings package and a simple if statement. If strings, which is a built-in package, and we've used it before, but this time we're going to use a new method on that package called contains. And we're going to look at the variable x, which each time we go through the iteration will be the current entry in our slice of strings named courses. Does it contain the word go with an uppercase G? So that will return true if the word go exists in the string we're looking at. Otherwise, it'll return false. So I can just say format.println go is found in x. And if I run this program, go run main.go, you know exactly what it's going to do. It looks at every entry, and we only get a true return from the method contains in the package strings for the first one. Go is found in Learn Go for Beginners Crash Course. Now that's great, and it's useful information, but it would be more useful to figure out where in that string it exists. So I can say something like, and, which has to be in quotation marks, and index is, and again, use the strings package. Strings.index is the method I want. I'm going to look at x, and again, I'm looking for go. And if I run it this time, go run main go, I get more information. Go is found in Learn Go for Beginners Crash Course, and index is 6. So as you know, since we start counting at 0, the 7th character in the string Learn Go for Beginners Crash Course is the beginning of the word go, G-O. So that's very useful. But we actually have more methods available to us in the strings package. So let's create a new string. New string is a variable called Go is a great programming language. Go for it. So now the word go exists twice in this string, and I already have written out and have copied to my clipboard some useful comments, the same as we did last time. So I'll paste them in. And there they are. That shows us the position of each of the letters or each of the characters in this string. So first of all, let's say format.println, and I'm going to say strings, here's another method in the package, has prefix, and we want to look at new string, and we want to look for the characters go with an uppercase G. Now if I run that, the first thing it's going to do is say, okay, we're going to print something to the screen. We're going to use a strings package. We're going to use the method has prefix and determine whether or not the string we're looking at begins with the characters uppercase G, lowercase o. So you know what's going to happen if I run this. It's going to return a Boolean. Go run main go. And the last thing printed there is true because this method has prefix returns true or false. Now if I duplicate that line and say has prefix Python and run it again, so I'll clear the screen, go run main go, we should get a false as the last output from our program. And we do. We also have has suffix, which works exactly the same way, but it looks for the last characters in the string. So if I duplicate this and change it to has suffix, and just look for the exclamation mark, and run this, I should get a true as the last output. And I do. Okay. Now just to explore a few of the other methods available to us, we can say format.println strings.count. And we're going to look at new string, and we'll look for go, like this. And as you might expect, that counts all of the occurrences in the string we're looking at. It looks for every occurrence of uppercase G, lowercase o, whether it's a whole word or part of a word, and it gives us that number. So let's run this. Go run main go. And it says it found it twice. Now if we look for a word that we know is not in there, like fish, so I'll duplicate this and change this to fish, what does it return then? Well, let's find out. Go run main go. It returns 0 because it doesn't exist at all. So let's have a look at another one. And here's one that's actually used in the ELIZA project as well. Format.println strings.index, and we're going to look at new string and look for go. So let's see what this does. Well, we can roll over it and read the comment. That will help us. Index returns the index of the first instance of substring in S or -1 if substring is not present in S. So let's run this. And if we look at our count here, it should return 0. Go run main.go. And it does. It returns 0 because at the very first position of this string we have go with an uppercase G. But if we change this to, say, hide this window, and change this to Python, which does not exist, it should return a -1. Let's find out. And it returns a -1. So what about the last occurrence of go? How might I find that? Well, I can do that too. So let's duplicate this line. And instead of using index, let's change it to last index and change it back to go. So we'll actually find something. And if you roll over this and look at the comment or look at the information about it, last index returns the index of the last instance of substring in S, or -1 if it's not found. So what should it return here? The last index appears to be 36. So it should return a 36. So let's open our terminal, go run main go, and it returns a 36. Okay, now these are all really useful, and there are more methods to be found in the strings package, which we'll be looking at in the next lecture. And one of the most obvious things you want to do if you're looking for the occurrence of a substring within a string, Typically you want to change it to something else, and we'll look at how to do that in the next lecture. But first of all, let's go over and have a look at ELIZA and see how some of these methods are used in that package. So back to ELIZA, I'm looking at doctor.go, and I'm looking at the same section of code I did last time around. And if you look at line 150, we're looping through matches, which is a slice of strings. And if we go look for matches, right up here, you see we're looking for life, I need, why don't, why can't, all of the things that might appear, things we're looking for in whatever the user typed. So back down to line 150, we loop through this slice of strings until we're completely through the entire life of strings, or we find a match, and we look for match is equal to matches I, so we're getting the current iteration, the current slice, the current entry in that slice of strings. And we're saying strings index looking for user input, and this actually, you can figure out what this does. It takes the user input and converts it to lowercase, and it says, can you find match, the current value in the slice of strings that I'm iterating through, can you find that anywhere in user input? And if you can, you get the position. And position will only be greater than -1 if it's found. So, as the comment says, we found the word or the words in matches in the user input string. So now we need to figure out how much to delete from that input. The word from should appear in there. So in the next lecture, we'll look for how to manipulate a string. In other words, to change something once we've found it. So now that we know how to search a string to find a substring, let's actually try changing the string itself. So we'll use some string manipulation methods built into the string package. So I'm going to delete all of this code in the project right now because we're not using it. And I'll just clean this up a bit, and now I'll delete all of this as well. So all we have now is a variable called newString. So let's search this string for the occurrence of the word go and replace it with something else. And we can do it this way. We can say if strings.contains, and we'll look for our variable newString. That's what we're searching. And we'll look for the word go, like that. And as you know from the last lecture, that returns a Boolean. It will return true if the characters uppercase G, lowercase o appear in the string newString, and it will return false if it doesn't. So we know that it's going to return true, but I'm going to put the check in there anyway, just so we can get used to doing it. So now that we have this, let's replace the characters uppercase G, lowercase o with something else. So we can just say newString is now equal to strings dot, and I'll use the method replace. So this actually takes, as you can see in the helpful hint that Visual Studio Code gives us, it takes a number of parameters. And the first one is the string that we're working on, which in our case is called newString. And what we're looking for is the second parameter, and we're looking for go, like that. We want to replace it with Golang. And the final parameter is how many times do you want to replace it? So I will actually say -1, which should replace everything with Golang. So now if I print this out, format.println, newString, and run the program, go run main.go. Our initial string is Go is a great programming language, period. Go for it. I run the program, and it says Golang is a great programming language. Golang for it, which makes no sense. So let's actually change that fourth parameter from a -1 to a 1. Only do it one time. So let's run the program again. Go run main.go. And now it says Golang is a great programming language. Go for it, which seems quite helpful. Now there's actually another method called replace all, which does pretty much the same thing. We can actually comment this line out and put a new line in here. newString equals strings.replace all, and it takes fewer parameters. My string, newString, what I'm looking for, go, and what I want to replace it with, Golang. And if I run this program, you know exactly what it's going to do. Go run main.go. And it replaces every occurrence of go with Golang. Okay, so that's straightforward. Now there's some other things you might have to do at some point or another, and this would be string comparison. So I'll just put a comment in here and close this terminal window. String comparison. So we've already seen things like this. I can say a variable a is assigned the value of a, uppercase. And then I can say if a equals that, then format.println, or whatever you want to do, a is equal to a, like that. And that'll work. And if I run this program, again, you know exactly what it's going to do. Go run main.go. So equality testing, or testing for equality of strings in Go, is just like every other equality test we've seen so far. You can use the equals comparison right here. We can say not equals, and we'd have to change this to is not equal. But you can also use greater than and less than. So let's do this. Let's say a is equal to a. Actually, let's make it even simpler. Let's just use hard-coded strings. I can say if the string a is greater than the string b, format.println, a is greater than b. And we're just doing actual hard-coded strings here. Let's put an else statement. Else format.println, a is not greater than b. Now what is that going to do? It doesn't seem to make any sense that you're comparing a character to determine which one is greater than the other. And yet, from a computer's perspective, or from your computer's perspective, this makes perfect sense. Otherwise, we could never sort things alphabetically. So let's run this and see what happens. Go run main.go. A is not greater than b. Well, that makes absolutely perfect sense if you think about what strings actually are. Remember that strings are a slice of bytes, or runes if you prefer. And those runes are actually int32s. So you can, in fact, do a comparison on strings. And it actually isn't just single characters. We can say if alpha is greater than, and let me find a word that comes before this. Let's say absolute. And we'll just leave the messages the same because we can follow along with what's going on here. If I run this, what do you think is going to happen? Is alpha greater than absolute? Well, let's find out. Go run main.go. And it says A is greater than B, which kind of makes sense when you think about it, because A, the uppercase A in alpha, and the uppercase A in absolute are exactly the same value, int32 values. But L actually comes after B in the alphabet, and the int32 value for a lowercase l is bigger than the int32 value for a lowercase b. So this does, in fact, make sense. So you can do comparisons on strings as well. All right, the last thing I want to look at in this case is another useful function that's built into the strings package. Let's say you're building a web application and you're asking someone to enter an email address. And they type it in, and it looks perfect to them, but what they actually type in is this. I'll create a variable called bad email, and it has a leading white space, and then it has whatever the email address is, me@here.com, and then two more spaces after it. That's the way they type it in. So it looks fine to the user, but from a computer's perspective, this is not an email address, and we can't actually send email to space me@here.com space, because that's not a valid email. So we want to clean up whatever the user enters a little bit. And we can do that by trimming the white space. And fortunately, the strings package has a nice method built into it that does just that. So we're going to clean up this email by using a method on the strings package. So we'll say bad email is equal to strings.trimSpace. And you can see what it does. Visual Studio Code gives us a little helpful hint here. Trim space returns a slice of the string S with all leading and trailing white space removed as defined by Unicode. So I can actually change that to a good email simply by calling the strings package, the method trim space, and passing it my bad email. And now to see what the final result is, I'll use format printf, and I'll put in my formatting string, and I'll put an equal sign with nothing after it, nothing before it. then %s is my string placeholder, then another equal sign, and I'll substitute bad email for that %s. And then, just so we can get another line, I'll just call format.println with no arguments. So what this will do is print equals, and then with nothing before it, the new email address, the new value of bad email, followed by another equal sign. And you'll see that all the space is gone when I run this. So let's run this. Go run main.go. And me@here.com has no leading or trailing white space. And that's a function you're going to use a great deal. All right, that's enough for this time around. Let's move on. So we've looked at how to find a particular occurrence of a substring within a string, and how to replace either the first or the last or all of the occurrences of that substring within that string. And we've also looked at string comparison, how to determine if strings are equal, if one comes before another, one comes after another, so on and so forth. But what if we had a string like this? And I'm going to delete everything in this main function. What if we have a string like this? I'll just call it str is equal to alpha, 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 alpha. What if I wanted to replace a specific one of these? Say maybe the third one, for example. Well, other programming languages actually have that functionality built right into their equivalent of the strings package in Go. But Go, for some reason or another, does not. But fortunately, it's so easy to work with strings in Go that we can write our own function to do this. And it's a great exercise. So what I'm going to do is create a new function here. And I'll call it replace nth. And it's going to take a few arguments. It will take the string we want to search in, which I'll call s, the words or characters we want to search for, which I'll call old, and what we want to replace that with, which I'll call new. Those are all of type string. And then it will take the position, which I'll just call n, and it's an integer. And it returns a string. So I'm going to go through this and write the code, and then go through it step by step with you. And then I'll post a version of the source code with extensive comments so you can refer to this, because it might be a little confusing at first. But don't worry, it's not that hard. And it's not using any functionality we've not already seen, with one minor exception, which I'll draw to your attention in a moment. So the first thing I'm going to do is set an index. And I'm going to call that I, and I'm going to assign it the value of 0. And the next thing I'm going to do is write a standard 3-part for loop. For j is assigned the value of 1, and j is less than or equal to n, which we received as a parameter, so it's the position we're searching for, and we'll add 1 to j every time through this loop. And inside of that loop, the first thing we'll do is to check to see if the current value of s from index I to the end of the string has the characters at all. In other words, we're searching for the current value of s to see if it has the characters we're looking for at all. And we know how to do that. We're using the index function. So I'll say x, which is just a variable I'm creating, is assign the value of strings.index, and we're going to search from, and this is the one thing you haven't seen yet, we'll search s, which is our string. In our case, it's alpha, 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 alpha. And we're going to look from position I, which the first time through will have the value of 0, to the very end, which means I'm leaving the second part of that out. So I'm searching from the current index of I in the string s until the very end. And we're looking for old. So you know how the index function works. If it finds the substring we're looking for, it returns the index. If it doesn't, it returns -1. So I can just say, if x is less than 0, then we did not find it. So we get out of the loop. Break. Otherwise, we have found it. And in this case, we actually want to do a little bit of math. To start with, that index I that we created back on line 14, I'm going to add to that the current value of I will be equal to I plus x. So x, as you know, is the index within the string s where we find the word we're looking for. Okay? The next thing we're going to do is to do a little comparison, a little test. If j the current index of our string, is exactly equal to n, then this is the start of the characters that we want to replace. So at this point, I can just do in one line, and I'll give you extensive comments and go through this momentarily, so don't panic. I can return exactly what I want, which will be our string, our starting string, from the beginning to the index I, where we currently are, which is the beginning of the old word. Then I will append to that, using the concatenation operator, what we want to replace that word with, which is new. We receive that as the third parameter on line 12. And we want to add also the substring from our original string at the index I plus the length of old to the very end of the string. So if you think this through, all we're doing on line 26 is we're saying, I want you to return a string composed of the following things. Everything in the original string up to the current index, so from the very beginning, position 0, to the current index where I am, which is the value of I. Then we want you to append the new, the word we want to replace, to that string. And then we want to replace everything from position I plus the length of the old word up until the very end of the string. And that will return it for us. Now, if j is not exactly equal to n, then we're not ready to do our substitution yet. So we'll add to the index of I plus equals the length of old. And of course, if it doesn't find it at all, we just want to return the string as it existed when it was passed to us, return s. So there's this function, and as I said, I'm going to go through this in more detail momentarily, and I'm also going to post a version of the source code with extensive comments, so you can play with this to your heart's content. But let's call this function back up in our main function. So I'll call this by saying string is now equal to replace nth, and I want to search the string str, which I defined on line 9. I want to look for alpha, and I want to replace it with, say, beta, and I want to do it in the third position. And then I'll just print it out. Format.println str. So let's run this program and let's see if we got everything right. So I'll open my terminal, go run main.go, and it says alpha, alpha, beta, alpha, alpha. It worked perfectly. So let's use our debugger to step over this code or step through this code and see how things look. And I'll put a breakpoint, say right here at line 20. Okay, and I might add some more as we go through this, but let's go to our Run menu and choose Start Debugging. And I'll open my console and go to my debug console. And it stopped right here in line 20. And I'll look at my debug, and there's all of my variables. So there's what I've passed the functions. So S has my alpha string. I'm searching for the word alpha. I want to replace it with the word beta, and I want to replace it at position 3. I is 0, j is 1, and x is 0. So let's say step. I'll say step over, and it goes down here. Have we found it the first time through? On line 26, well, I'll step once to see how it updates our variables. So right now, I is equal to I plus x, so I currently has the value of 0, j is still 1, x is still 0. Let's keep going. Step. And it adds 1 to I. So we'll step through that and see what I goes to. I is now equal to 5. Why is I equal to 5? Because I started as 0, and we added to it the length of alpha, which is 5 characters long. So let's keep going. Step. It looks in the index package to see if it can find the occurrence of our search term, alpha, and it will. So let's say step over, and step over that. And we have found it, but is j equal to n? In other words, is it the right one to replace? Well, let's step and find out. So it checks to see if j is equal to n. J is not equal to n, so it adds the length of our old search term, alpha, to the index of I. And if we step, you'll see that I goes from 6 to 11. Now this time it should actually find it in the right position. So let's step, and we'll step over that so we don't have to go through the strings package and watch all of its magic take place. So I'll step over. We'll just check to see if x is less than 0. I'll step. It doesn't break out. And now we have found it, so we add I and x together to give us our new value for I. So we'll step. I goes from 11 to 12. And then we check to see if j is equal to n. Let's step into it this time. And we have found it. So now it's going to build and return our string. So let's step. And we're back in our function call. String now is equal to alpha, 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 alpha. But when we step once, beta is now in the correct position, and we just print it out. So I'll stop debugging at this point. So as I said, I'm going to post a version of this source code with extensive comments, which will make things ever so much easier for you when you go through this code. And I do encourage you to go through this code, because this is using everything we've learned about strings so far, about the strings package so far. We're searching for things, we're using the index function, and it's all relatively straightforward. But you need to play with it enough that you actually start to think in Go. And that does take a little bit of time and a little bit of commitment. So I encourage you to play with this function and see what else you can do with it. And in the last lecture in this section, I want to look at how we can manage the case of a string. And I'm not talking about case as in the switch statement, I'm talking about upper and lowercase letters and why you might want to play with that when you're working with strings. So the last thing I want to look at in this section is dealing with case. And as I suggested in the last lesson, I'm not talking about the case you find in a switch statement or a select statement. I'm talking about upper and lowercase letters and why we need to pay attention to those. So I'm going to delete, as I usually do, everything except for an empty main function. That's where we'll start. And we're going to start with a case. And let me get rid of this breakpoint because we don't need that anymore. And I'll close this and look at our Explorer. Okay, so here I'm going to start with a string. My string is assigned the value of, this is a clear example of why we search in one case only. And you could probably guess what I'm going to do based upon this. And I better spell string right. Okay, so there's my string. I have one variable, and I want to search this. And I want to search it for the word this. So the problem is, I can do this if strings.contains and look for the word this. And I'm looking for it in the variable my string. That will return true in the case where it finds exactly this substring in the string my string. But it won't find this, because as you know from our comparison operator test with strings, those are two different things. As far as the Go compiler is concerned, the uppercase T followed by a lowercase his is not the same thing as an all lowercase this. So what we typically do, in order to make things absolutely simple, is we'll create another search string. Search string is assigned the value of, and I'll use the strings package again, and I'll use the toLower function. And I'm going to pass it my string. And now I don't search my string, instead I search this. And if I do that and finish my if statement, I'll say format.println found it. Otherwise, I'll say format.println did not find it. Okay, so let's run this program as it is right now, and this should print out found it, because I converted my search string, or my string, to search string, which is all lowercase. So if I say go run main.go, it will say found it. But if I, again, return it to the form that it was before, by pasting that in there and then commenting this out so I can run this program, this time it won't find it. Go run main go. Did not find it. So what we typically do is convert what we're looking for to either all uppercase and only search for uppercase characters, or to all lowercase and only search for lowercase characters. And that makes things ever so much more simple. So let's restore this to what it was, and we'll make this search string. And let's look at some other examples. Other things you can do with case. So other case functions that are in the strings package. So I can just say format.println, and I can say, let's do the lowercase one first. Strings.toLower, and myString. Try that again. myString. And then I'll duplicate this 2 more times to show you 2 more functions. Just as there's a toLower, there's a toUpper. And we also have one called title, which is a little bit different, but you might be able to guess what it does based upon the method name. So let's clear the screen and run this. So first of all, we see that we found it, and then we see the output of those 3 methods. toLower takes whatever it finds and converts it all to lowercase letters. toUpper takes whatever it finds and converts everything to uppercase letters. Title actually just changes the first letter of every word that it finds to an uppercase character, and it leaves the rest alone. So if I go back up here, for example, and change this to all caps, example, and run this again, and pay attention just to the last line of output, you'll see that example stays in all uppercase letters. So here's a bit of a challenge for you. I would like you to modify this program such that the final line of output has all title case. So in other words, example shows up, well, the rest of the words will show up exactly the same, but example will be uppercase E, lowercase XAMPLE. And you should have everything that you need to make that happen. So take a few minutes, work it out on your own, and then come back, and in the next lecture I'll show you how I approach this. And it's relatively straightforward. The answer is right on the screen in front of me right now. So give it a try, and I'll show you how I did it in the next lecture. So how did you make out with that oh-so-simple challenge? Hopefully it wasn't terribly difficult for you. As you probably figured out, the change needs to be made on line 22. Now you could have done this in several lines. You could have, for example, created a variable in between these and then used that variable. Or you could, as I'm going to, just do everything in one line. Just by replacing this, myStrings, with strings toLower myString. And if I run the program now, what's going to happen is what will get evaluated first on line 22 is myString will be passed to the strings package, and the toLower function will convert the contents of myString all to lowercase letters. And then those, the lowercase letters, are passed back into the strings package again and passed to the title function, which converts everything to title case. So if I run this, go run main.go, it does exactly what I want. There is the word example with just an uppercase E. And of course, we can use the same simplification of code up here. There is no need to create a variable called searchString. I can just take this out of here, cut it out of there, delete this line entirely, and replace searchString with a call to the toLower method in the strings package with myString as argument. And that will run exactly as expected. Go run main.go. Okay, so you can see that did exactly what I wanted. Now, we've used this toLower function here a couple of times. Right here, well, actually 3 times. Once on line 11, once on line 18, and once on line 20. And if you go and look at the doctor.go file in ELIZA, which I happen to have open right now, you'll see that it's used here as well. If I do a search in here for toLower, you'll see that it's used 4 times. Once on line 150, once on line 155, and once on line 164. Actually, twice on line 164. And in every case, what we're doing is simplifying our search. So everything is converted to lowercase, and we search one string against another using only the lowercase values. Which is why, when you scroll to the top of this file, we go to the top of the file and look at matches, you'll see there's not a single uppercase letter to be found anywhere here. Even the word I, or I've, or I'd. In every case, everything is lowercase, because that's what we're searching against. All right, so that concludes our overview of manipulating strings in Go, and it's time to move on to the next section. So in an earlier section of the course, we wrote this application, our little rock, paper, scissors game, and it works very well. So if we open the terminal for this and type go run main.go, it does exactly what we want. Game is played for 3 rounds, best of 3 rounds. I can type rock and get the result. I can type paper and get the result, and I'm losing badly here, and I'll type scissors this time. And it's a draw, and finally we can just hopefully finish the game this time. It's a draw. It's a draw. There, the computer won. So that's a great little game, and it works in the terminal. In this section of the course, what I want to do is to take advantage of the area where Go really shines. And that's to take this application and convert it from a console-based application to something like this. So let me go to my web browser and bring this up. And here we have rock, paper, scissors as a web application. A very simple web application, but one that covers all of the things that we learned, or many of the things that we learned in our rock, paper, scissors game, and translates it to the internet. So here I have the application running, and it's one web page, and I'm going to choose rock. And this web page communicates with a Go application running in the background, sends a request over the internet to my application, and the application sends a response back. And I see that this time I chose rock, the computer chose scissors, and I won. I'm doing much better this time. So now I'll choose paper. And this time the computer won. And now I'll choose scissors. And the computer wins again. This is not my lucky day. In any case, this is what we'll be doing in this section of this course. We'll start with a very simple application that essentially writes hello world to a web browser, and we'll gradually build upon that until we have a fully functional version of our rock, paper, scissors game running as a web application. So let's get started. So let's get this project started. And what we're going to do this time around is basically the equivalent of that very first Go program we wrote, Hello World, but this time instead of writing Hello World to the console, we'll send it to a web browser. So I have Visual Studio Code running, and I have an empty window, and I'm going to open a folder. So I'll open a folder, and as usual, I'll put it in my Visual Studio Projects folder, and I'll create a new folder called Rock, Paper, Scissors, Web. And I'll open that. And now I'll open my terminal and type go mod init. Let's try this again. Go mod init. And I'll just call it my app. And that creates my go mod file. And now I'll create a new file inside this folder, as usual, called main.go. And in my main.go file, I'll give it its package declaration, which will be main. And I'll give it a function. Func main, and it does nothing. So let's get started. So the very first thing we want to do here is to, believe it or not, start a web server. Now, lots of programming languages have built-in web server functionality. PHP, for example, allows you to serve PHP files, and so does Python. But the nice thing about Go is that it's not just a development web server that's built into the standard library. It's a production-ready web server that can handle thousands of simultaneous connections. So we'll do a really simple example here. And the first thing I'm going to do is create a new function outside of the main function. And it's going to render a home page. We're actually not going to do the page in this lesson, but we'll get started. So I'll call this func homepage. And it's going to take 2 arguments. 2 arguments you have never heard of before because they're things we've not used in the standard library, but they're relatively straightforward, and I'll explain them to you. So the first parameter I'm going to call w, which is just my variable name, and it's going to be of type from the standard library, the HTTP package, which stands for Hypertext Transfer Protocol, and that's how the internet renders web pages, using hypertext. And the specific type is http.responseWriter, right there. And the second argument I'll call r, and it is a pointer to the HTTP library or package, and it's of type request. So there. This takes 2 arguments. Now, what is a response writer and what is a request? Well, let's start with the request. If I'm on my computer, and I start up Chrome or Firefox or whatever my favorite web browser is, and I decide to go to, I don't know, let's say google.com. So I click in my address bar and I type in google.com. What happens at that point, as soon as I press return or enter on my keyboard, is that my computer, my web browser, builds a request and sends that request out to the internet. And that request says nothing more than, hey, I want to get google.com's default web page. And it sends that request off. And then it waits for a response. And the response is actually just HTML, which stands for Hypertext Markup Language. It's a text file that describes what a web page should look like, what images are on the page, what text is on the page, whatever's on that web page. So you send a request, and we're waiting for a response. Now, in this case, because we're building an application that's not a web browser, instead it's a web server, we receive the request, and we build the response. And that's all that's going to happen in this particular function. So rather than actually building a web page, I'm going to use the format package, and I'm going to call the method fprintf. And I'm going to send back hello world. Okay? And I see I didn't import format, so let me do that. And close this parentheses. Okay, so let's save this. And in our main function, I need to call that homepage handler. We call that a handler, okay? It handles requests to specific web pages or specific parts of a web application. And we do that again using the HTTP package. HTTP dot, and I'm going to call handle func. And I'm going to look for this as the request. And think of this part right here, as the URL that's being requested. So when you go to a website, but don't specify anything after the domain name, so I go to google.com, for example, you're actually requesting the top level of that web application, the home page, in other words. So that's what this stands for. / just means whatever server I'm running on, the default page. And when that request comes in, I want to call homepage, the function up here, okay? So now we have a main function that has a handler function that's never ever going to get called because we don't actually have a web server running right now. But look at how easy it is to start a web server in Go. I'm just going to type http://listen and serve. This one line with this argument, we have to listen to a specific port, and it starts with a colon, and it is a string. I'm going to listen on port 8080, and I'm just going to use nil as the second parameter, and we can ignore that for right now. This one line, on line 15, starts a production-ready web server and listens on port 8080, okay? So just to make sure that we know something is happening, I'm going to write one line in here. Log, which is a built-in package in the standard library, print line. I'll just say starting web server on port 8080. And we'll get to ports in a moment, okay? fprintf. Good thing I noticed that typo. Let's try that again. fprint. There. And it requires another argument here. It requires a response writer. I'm having a bad day. That's better. Okay, now there are no errors. So the format fprintf, or fprint, is pretty much the same as format print, but instead of printing to the standard out to the terminal, it actually prints to our response writer, which is w. So we have this parameter, w, which is of type http://response-writer. All that's doing is magically, behind the scenes, because we have such a rich standard library in Go, that's building the response that is suitable for a web browser to receive. So let's run this application. I open my terminal window, and I'll just drag this up a little bit so we have a little more room. Go run main.go. And it says starting a web server on port 8080. So this is running. Now I'm going to switch to my web browser. And I happen to be using Firefox, but any web browser will do. And I have a new window, and at the top here I'm going to type http://localhost, LOCALHOST, and this is where the port comes in. I'm going to put what I specified in my main application, port 8080. Now, web servers typically listen on port 80 if it's an unsecure connection, or port 443, which is a secure connection. It uses SSL encryption. But we're running in development, and if I try to specify port 80, I'm going to get security errors because the first 1024 ports on a computer are actually protected. But if I go anywhere above that, like 8080 for example, I can do that with no problem. So I'm going to port 8080, and I hit return, and look, it prints hello world to the web browser. Now, it's not very pretty. It's just a little bit of string. But as we move on in this section, we'll actually begin to build a much more complete web page. So this gets us up and running. And look at how few lines of code are required to make that happen. I have three lines in my main function and 1 line in my homepage function, and that's it. It's very straightforward. Now, one word of caution. If I was to come here right now when I have this application running and just hit the X and close this terminal window, that web server will continue to run in the background, which means I won't be able to start it again because something's already listening on port 8080. So to get out of this, just make sure you're in your terminal window, hold down the Control key and press C and release it. And that will stop the application. Okay? And if you forget to do that and just close the window like this and leave the application running in the background, just quit out of Visual Studio Code and start it back up, and things will be returned to normal. All right, let's move on. So far, our web application doesn't do anything terribly exciting. So I have the application running right now, as you can see, and the code in front of me is exactly as it was at the end of the last lesson. And if we go back to our web browser and look at it, it just prints the text hello world to the browser window. Now, let's make it a little more interesting, and just a little bit. We'll take this in easy steps. So I'm going to create a new variable here, which I'll call HTML. And that will be a string, and it's just going to have this in it. Strong, in pointy brackets, hello world, and then in pointy brackets, /strong. Now, the first strong, right here, that is an opening HTML tag. And as I said a couple of lectures ago, HTML stands for Hypertext Markup Language. And that is the language used to write web pages. And it's a very, very simple language. You typically surround text with tags. And in this case, strong is a tag. So the opening strong in pointy brackets is the opening tag. And the closing strong with a slash in front of it at the end of the string is the closing tag. And everything between those is affected by the tag strong. Now what strong does is render text in boldface. So I'm going to take this hello world out of here and replace it with the HTML variable I just created. Now you would think if I stopped and restarted the application and revisited the page that I would then see hello world in bold text. But that's not going to happen, and I'll show you why. But let's do it anyway. So I stop the application, I start the application, I switch back to my web browser, and I reload this page, and you see we actually get the entire HTML rendered to the screen. And that's because we've not actually told the web browser that it's receiving HTML. So let's go back and fix that. Just after I declare the HTML variable and assign some content to it, and before I call format.fprint, I'm going to put this in. W, which is my response writer, header with opening and closing parentheses, dot set. And inside of that, I'm going to put 2 parameters. The first one is content-type with a capital C and a capital T, and then a comma, and then in quotation marks again, text/HTML. What that one line does is it tells the browser you're about to receive some HTML. And that's because we're sending it a header, which the browser receives, but doesn't show us, or doesn't show the end user. But that instructs the browser, here's the kind of content you're going to receive. So let's stop the application again, and start the application again, and go back to our browser, and reload the page. And now you see hello world in bold text. And if I actually right-click on this and choose View Page Source, you can see that what's actually being rendered there is strong hello world strong. That's what's being sent to the browser. But what's being displayed to the end user is the formatted HTML. Now you'll notice Firefox at least says this is not valid HTML. Don't worry about that right now. We're just interested in getting some content rendered to the browser window. And we'll take care of actually building a correctly formatted page in the next lesson or the one after that. So back to our code. It seems that I can actually render HTML. Now, it would be really irritating to have to write your HTML as a string variable in your Go program, because anytime you want to change it, you have to recompile your program, and it becomes very, very tedious to do that. So in the next lecture, we'll figure out how we can have our HTML sitting in its own file and tell Go to load that file and render it to the end user. And we'll get started on that in the next lecture. So in this lesson, I'd like to modify our program so that we don't have to write our HTML, as we do on line 10, right into a string variable and have Go serve that for us this way. Instead, I want my HTML file, and in a busy web application, you might have hundreds of pages. I want to have my page as its own file, and it will end with .html. So I have the program running, so I'm going to stop it by hitting Control-C and close my terminal window. And over on my left-hand side, under my Explorer, I'm going to create a new file by clicking the plus sign. And this is not going to be a Go file. I'm going to call this index.html. And I use the extension HTML because this is a web page, and that's how web pages are typically named. So I'll create that file. And because we're using Visual Studio Code, we can actually cheat a bit. We can use Emmet, which is built into Visual Studio Code, to write a simple HTML file for us. So let's do that, then I'll go through the contents of that file. And you do that by opening the HTML file, which I have open right now, and just typing HTML:5, and then hitting the Tab key. And Emmet helpfully creates a default empty web page for us. So let's look at the contents of this. The very first line that I see in my file declares the document type. That's what's on line 1. And that says to the web browser, this is an HTML page. Specifically, this is an HTML5 page, which is the standard for web pages as I record this course, and probably will be for several years to come. The second line is ignored by the web browser. It's not shown to the end user, in other words, but it tells the web browser what language I'm writing this in. And EN, of course, stands for English. Then from lines 3 to line 8, we have tags, the head tag. Just like we had the strong tag in our main.go file, this is a head tag. And very little of what you see inside the head tag is actually shown to the end user. Line 4 declares the character set, UTF-8, so we can use standard English characters, or we can use the Greek alphabet or kanji. It just allows us to render different kinds of languages or different kinds of text to the end user. The next line, meta HTTP equiv, x-ua, and so on and so forth, that simply tells the browser, I'm a pretty modern web page, so render me using modern standards. Okay? And that's an oversimplification, but it's sufficient for our purposes today. Line 6 tells the browser what to do when the window is resized. So make sure that this window takes advantage of all of the screen real estate that you have and set the initial scale to 1. Don't zoom in, don't zoom out, just show the page as it would appear by default. Now line 7 actually does show up in the end user. So if I go back to my web browser, which I still have running, the application's not running, but it's still running. We can still see what was shown the last time I hit this. At the top of this tab, it says localhost 8080. And you notice if I go to a site like Google, if I go to www.google.com, that tab actually gets named Google. And if I view the source on this page, you will see, well, actually it's kind of hard to find on the Google page, but somewhere here, let me search for /title. Right there. So way over here, you'll see that there's a title tag right here. And that determines what shows up at the top of a browser window. So to close this, because it's really confusing, and go back to our code, whatever I put in here is what's going to show up. So I'm going to put in the name that this is eventually going to use. Rock, comma, paper, comma, scissors. Okay? Now, I'd like to see this change. And I don't want to write all of the code necessary to serve this from my web application right now. So what I'm going to do instead is go back to my web browser, open a new tab, and say File, Open, which is right here, Open File. And it's named slightly differently on Chrome, but you'll be able to find it. Then I'll go to my Visual Studio Code projects, and I'll sort by date modified. There it is. And I'll open this index.html file. And that allows me to see the changes as I make them. So I have rock, comma, paper, comma, scissors, and nothing showing up here. Well, why is there nothing showing up here? Because if we go back to our code, what shows up in the main part of your window is what's in the body tag. So if I put in here, for example, rock, paper, scissors, and then save this, and switch back to my web browser, and reload this page, there's the text. Now that's not very attractive. Let's see if we can make this a little bit better. So I'll come back here and I'm going to introduce a new tag. And this is called the title tag. And it goes like this, H1. It's actually not called the title tag, but it's used to make titles. It's the H tag, and it has several levels. H1. Now if I save that and go back to my web browser and reload the page, you'll see that it changes the formatting of my rock, paper, scissors. So I'll reload. And there it is. Now it looks more like a title. Still not terribly attractive, but it is getting closer. So now, underneath this, I'm going to put a tag that does not have a closing tag. It exists by itself. HR, which stands for horizontal rule. And I'll save this and go back to my web browser and reload it. And now I have a horizontal rule. Again, not terribly attractive, but we'll take care of that before too long. Finally, let's go a little bit further here. I need to have buttons. If you'll recall, when I showed you in the introduction to this section of the course, I have 3 buttons at the bottom. One for rock, one for paper, one for scissors. And what I'd like to be able to do is to make those buttons right now, and I'll have them do something later on, okay? So what I'm going to do, first of all, is create a button. And you do so by using a tag, not surprisingly. That's how you create almost everything in HTML. And it's called button. And it's going to have nothing in it right now except an opening button tag and then a closing button tag. And I'll say rock. Then I'll duplicate that twice. And I'll say paper. And I'll say scissors. Okay. So that will create 3 singularly unattractive buttons. Let's go back and have a look at them in our web browser. I'll reload this. And there's my rock, paper, and scissors buttons. Okay. So this is a starting point. What I'd like to do in the next lecture is make this a little bit more attractive and create some places on this page where I can actually put the responses I'm going to get from our Go web application. So when I click rock, what I want to have happen, and it won't all happen in one lecture, but it'll all happen in this section. When I click rock, I want it to send the fact that I've clicked the rock button off to our web application, have it roll for the computer, and send back the results for that round. In other words, I rolled rock, the computer rolled whatever the computer rolled, and who won that round. Okay? So we'll get started on that in the next lecture. So let's improve our home page a little bit. And I'm going to do that first of all by coming in here in my index.html file, and below my horizontal rule, I'm going to create 3 places to hold feedback after the user clicks rock, paper, or scissors, whichever button they click. So each one of those is going to be a paragraph. And in HTML, the paragraph tag looks like this. P in pointy brackets for the opening tag, and /P in pointy brackets for the closing tag. So I'm going to have 3 paragraphs. One for what the player chose. So if I click rock, I want this paragraph to say player chose rock or something like that. One for the computer's response, so what they chose. So if the computer chose paper, for example, it will say something like computer chose paper. And then finally, underneath that, a 3rd paragraph where I'm going to have the result of that round. Who wins, in other words. Now, these are 3 paragraphs, and I'm going to need some means of telling this web browser when I need to change the content of a paragraph, which paragraph I want to change. And I do that in HTML by giving each of these an ID. So inside the opening tag, I'm going to put in what's called an attribute. And this attribute is named ID. And attributes always begin with the name, followed by an equal sign, followed by something in double quotes. You can use single quotes, but I tend to use double quotes. And I need to give each one of these meaningful names. So I'm going to call this one player choice. And I'm not going to use any spaces in it, and you shouldn't either, because it's just bad practice to do that. Instead, I'm going to use snake case, where I have a word, and anywhere there'd be a space, I use an underscore, okay? So I have player choice. That's the first one. The second one, the second paragraph, is also going to have an ID, and that's going to be equal to computer choice. What did the computer choose? Rock, paper, or scissors? And finally, this one, I will name ID equals round result. Who won that round? Okay? So I have those three paragraphs. And just so I can see what they look like, let me put some default text in there. So I'll say player choice, and inside of this one I'll say computer choice. And we're going to change this before too long, so it doesn't really matter what you put in there. I just want to see where they're going to show up on the page. And finally, I'll just put result here. Okay, so I'll save that. Switch back to my web browser, which still has that page open, and I'll reload the page. So you'll see you have player choice, computer choice, and result, and my three buttons. Now this is actually not that attractive, and it certainly doesn't look as good as what I showed you in the introduction to this section, so let's take a little bit of time right now to clean this up. And in another browser tab, I have this site open. Bootstrap, or it's called getbootstrap.com. It's the Bootstrap site. And Bootstrap is what's called a cascading style sheet framework, or a CSS framework. And it was developed by the people that run Twitter. And it is very, very popular. And what I'm going to do, and this is kind of really interesting if you think about it. If you've never done this before, you'll find this hopefully moderately impressive. I'm going to scroll down the page a little bit to where it says JS Deliver. When you only need to include Bootstrap's compiled CSS, that's the part I'm looking for. And this is the text that I want. So I'm going to click the copy button, copy, and I'm going to switch back to my IDE. And at the top, just before the title tag, I'm going to hit return there. So on line 7 in my code, so after the meta name equals viewport and before the opening title tag, I'm going to paste in what I just copied, okay? And then I'll save it. Actually, I'll tab this over to make it a little more attractive. And save it. I'll get rid of this blank line because I'm a perfectionist, okay? Now I'll save this. Now I'll go back to my web browser, and you'll see very little change initially. But I'm back to my rock, paper, scissors page, which I have open in Firefox in my case. I'll reload it. And look how everything changed. It changed a little bit. Now the buttons even look a little bit better. Well, we can do way better than this. So let me go back to my IDE. And now that we've included Bootstrap, we actually have much more control over the way that things look to the end user. Bootstrap is purely a convenience. And it saves us the trouble of defining a whole bunch of styles on our own. And for our purposes in this course, this is more than sufficient. So the first thing you need to know about Bootstrap is it expects the contents inside of the body tag to exist in something called a div, or a division, D-I-V. And it expects that division to have an attribute named class. And it needs that class to be one of a number of things, but for our purposes today, we're going to use container. And you got to spell it right or it's not going to work. Now when I finished typing that div and closed my pointy bracket, Visual Studio Code helpfully wrote that part for me. I'm going to cut that and move it down just before the closing body tag, and I'll paste it in there, okay? And because I like to keep things nice and clean, I will simply tab everything over. So my opening div and my closing div are at the same space horizontally. So now I've done that. Let's just save this and see what change that did. So I'll come back here and reload this page. And look, now it's in the middle of the page. That's perfect. We're getting closer anyway. But I still think that the title is awfully close to the top. And as I said, I'm a bit of a perfectionist. So I'm going to add one of the Bootstrap classes to line 13, my H1 tag. And I'll say class equals MT for margin top dash 4, not 34, 4. And all that does is give it a margin at the top of 4 of some kind of unit. And it doesn't matter what that unit is for our purposes. All we care about is what happens. So watch rock, paper, scissors at the top of the browser window. Not in the tab, but the big title. When I refresh the page, it pushes it down a bit. That looks better. Okay, let's go back to our IDE. And now I want to format these buttons a little bit more, okay? And again, as you always do with Bootstrap, use the class. And class stands for Cascading Style Sheet Class. What kind of styling do you want to apply? And Bootstrap gives us a bunch of things. So if I just put BTN there for button, okay? And go back and reload this. No, it didn't seem to change it very helpfully. It doesn't look much like a button right now. But when I go back to my IDE and add, say, btn-outline-secondary, like that, okay? I happen to know these class names really well, and you have a link to the Bootstrap site right on the course resources for this, so you can go read about these at your leisure. But when I do that, look what it does to the button here. I'll refresh the page, and that looks way more attractive. Let's do a similar thing for each one of these. So I'll give each one of these a class as well. Class equals button, and I'll make this one button outline, say, danger. And I'll make this one class equals button dash outline, and I'll make this one success. Like that. And it has to be in quotes, so let me put the quotes in there. And save this. And go back and reload this page. Reload. Now that looks much better, but let's improve it even more. We just want to have a slightly more visually appealing site. So I'm going to come back in here, and I'll put some instructions in. Let's say, right here, I'll say BR, which is a tag you haven't seen yet. That just means line break. And I'll put another line break in. It's as though you were hitting return in a word processor, for example, or the format.print line when we're writing to the console. I just want a couple of blank lines. And then I'll put some instructions, like the instructions can go here, right above this. I can say P for a paragraph tag, choose rock, paper, or scissors. And I'll put an exclamation mark. And above that, I'll put in, say, an HR, another horizontal rule, just like we have on line 14. And I'll get rid of this blank line, save this, go back here, and reload this page. That looks better. Okay, so these things, player choice, computer choice, and result, those are just placeholders. And we're going to be changing those based upon the response we get from our Go application when we tell that Go application that we've clicked either rock, paper, or scissors. So let's get rid of that placeholder text. And I will put in, and this is something you're going to see if you ever work in HTML very much, I'll put in what's called a non-breaking space. So it begins with an ampersand, and it has NBSP semicolon. And all that says is, there's some content inside this paragraph tag, just make it a space. Because the way the web pages are rendered, for example here, if I do this, put a whole bunch of spaces between computer and choice, and save this, and go back and reload this page, you'll see the computer choice really only has one space in there, even though I typed probably 15 or 20. So an NBSP says, put a space in there and make it one space, a non-breaking space. So I'll replace this with ampersand NBSP, and replace this with ampersand NBSP, and save this, and go back and reload it, and just make sure everything looks right, and it does. Okay, so next we're going to have to start working both on this page by writing something called JavaScript, and you might be familiar with it, and if not, don't worry about it, I'll go through the basics. And we also need to write another handler, or write some more code in our project that actually does the same thing that we did in our console version of rock, paper, scissors, and that actually extends our web functionality to listen for another path. Right now we're just listening to /, which is the default of our website, and we also need to listen to play. And finally we need to actually use Go's functionality to serve our web page that we've been working on for the last couple of lessons, to serve that up to the end user instead of the hello world that we've been sending up until now. So we'll get started on that in the next lecture. So our index.html page is starting to look pretty good, and we might make some changes to it later on, but let's see if we can hook this up to our Go code. So I'm going to go back to my main.go file, and right now we have one handler function, which points to homepage, and that is, of course, our homepage func, which is itself an HTTP handler. And all it's doing is creating some HTML, storing it in a variable, and setting the header, and then sending it off using format.fprint. So I'm going to delete all of that, because we're not going to do it this way. Instead, we're going to take advantage of another package built into the standard library called HTML template. And what I'm going to do is parse our HTML file into the necessary format and then send that to the browser. And it takes care of setting the header and all of those things for us. And you do that like this. I'm going to create a variable called t for template. I'm going to check for an error, and that is assign the value of from the template package, HTML template, dot, and the method we want is called parse files, plural, like that. Okay? And it takes an argument. And the argument it takes is the path name, the full path name, to our index.html file. Well, that's right beside this method. We're beside the homepage code in main.go, so I can just put index.html. And that will actually parse it. And it'll also check for an error. So let's look for an error. If error is not equal to nil, then I'll just say log.print line, and I'll print out the error. And then I'll just return, because I don't want to go any further. Something went wrong. But assuming we got past that, what I want to do now is execute that template. And that is the magic that sends it to our response writer. So again, we're checking for an error, and it's assigned the value of or equal to t, the template variable we created on line 11. And now that has a method called execute. And we're going to send it what we want to write the content to, which is our response writer, w. And it has a second argument, which I'm going to call nil. And that's where you would pass data to the template. But we're not doing that in this lesson, so I'll just pass it nil. And we check for an error. And once again, I'll just copy this, save some typing, paste it right here, and that should do it for us. That should actually execute our template and write it to the browser. So let's open our terminal window, and I'll type go run main.go. And of course I have an error because I need to save to get rid of that extra format. That'll take care of that. Go run main go. And now it's listening on port 8080. So let's go to our web browser. And this is the raw HTML file we're looking at. And I'll just replace the URL with http://localhost:8080. And everything worked the way that it should. There it is. So we have our HTML showing up here, and if I inspect the page or look at the view page source and refresh this because that's cached, there is our generated HTML. Okay, so now we have a means of actually writing to the browser in a slightly more sophisticated fashion using external HTML files. Let's go back and just generalize this a little bit. So I'm going to quit the application, close this. What if our site has more than one page? Well, I don't want to copy this code over and over for every handler. And to be honest with you, we're only going to have one handler that serves up an HTML page. But it's good practice whenever possible. I might use this a lot. So I'm going to cut all of that code and come down here and just create a function. And I'll call it render template. And it will take two parameters. W, which is an http.responseWriter, right there. And it will also take the name of our page that we want to render, which I'll just call page, and it will be a string. And I will paste that content in there, and rather than hard coding index.html here, I'll allow this function to accept any HTML template, the name of it, which I'll pass as this parameter string, this string parameter called page. And back up in my homepage function, all I have to do now is call that render template and pass it my response writer and the name of the file I want to render. And if I run this again, this should work exactly the same. Go run main.go. And I'll switch back to my web browser and just reload the page, and it should still work. And it does. All right. So now we have our page being served up in a slightly more intelligent fashion. So the next step is to begin to incorporate some of the code from our rock, paper, scissors console version and put it into our web version. And we'll get started on that in the next lecture. So now that we have our HTML file being served the way that we want it to, and we have to go back and make some changes to that, but we'll do that in a while. But right now, we want to start implementing the logic that takes some of the code from our console version of rock, paper, scissors and implements it in our web application. So the first thing I'm going to do is create a new function, and I'll put it right here in my main.go file in my rock, paper, scissors web project. I'm going to call this function play round, because this is what's going to happen every time we play a game on our website. And it is going to take two parameters because it's going to be a handler. So with every handler, every web handler in a Go project always takes an http.responseWriter, and it takes a pointer to an http.request, just like our homepage function on line 9. So that's going to exist, and it's not going to do anything right now, but I'm going to create that. And then down in our main function, I'll create another handler that actually points to that. So I'll put it right here, just before that. I'll say http dot, and again, just as we are in line 19, handle func, and it's going to be this time to the URL /play, whatever our web server is /play, and it will go to the play round. Okay, so now we have, it doesn't do anything yet, but we have a means of getting to the part where we're actually going to play our game. Okay? Now, I don't want to recreate all of our code that plays rock, paper, scissors by hand, right from scratch. So what I'm going to do is go back to my Explorer, and I'll create a new folder in my rock, paper, scissors web project, and I'm going to call that RPS for rock, paper, scissors. And inside of that, I'll create a new file, and I'll just call that rps.go. And this will be a package. So I'll give it its package declaration, package rps, and I want to have some code in here. So what I'm going to do first of all is go back to my rock, paper, scissors project, the console version, which I happen to have open right now, and you probably still have a copy of it. If not, you can just go grab the source from the appropriate lecture and download it. And once you have it open, as I do right here, let's copy some content. So I'm going to look, first of all, at the main.go file, which is the only file that's of interest to me. Well, I know I have some constants, and I might use those, so I'll copy those and switch back to my web project, make sure I'm looking at rps.go, and paste those in. And now I'm also going to have a function in here, a function for playing a round. Now, if you think about it, if we go back to our web browser, we have 3 paragraphs hidden in here. One for what the player rolled, one for what the computer rolled, and one for the outcome of the game. So let me go back to this function again, back in my IDE. I'm going to create a function that's going to play a round. And if you think about it logically, I need to know, whenever the round is played, who won, what did the computer choose, and what was the round result. So really, when you think about it, I want to have maybe an integer that says 0 for a tie, 1 for the player 1, or whatever it may be. And I also need 2 strings. What did the computer roll, and who won the round? Okay? So I'm going to create a function. I'm not sure what parameters it's going to take right now, but I'll call it play round, and I need it to be visible outside of this package, so I begin with an uppercase letter. So I'll leave the parameters it's going to receive empty for right now, but it's going to return 3 things. An integer, which will be the numeric representation of what happened that round. Either it was a tie, the player won, or the computer won. And it's going to return a string, which would be what the computer chose. So the computer chose rock, paper, or scissors. So just a message I'm going to print on my web page. And round result. In other words, who won that round. But that, of course, is not a variable name. That is a string. Those are the 3 types that I'm returning. Okay? So right now, just so I'll be able to compile this, I'll just say return 0 and a string and a string. Okay? So now that will actually compile. It doesn't do anything yet, but let's go back and look at our actual console version of this game and see the kind of things that are taking place. Well, there's really only this main function to worry about right now. So we seed our random number generator. We'll have to do that, definitely. So I may as well copy that Actually, I'll type it by hand so my imports get done automatically. So let me go back to this function and say rand.seed, and it's going to take time.now, and it's not Unix, I want Unix Nano. So that will seed our random number generator. So that's definitely something we're going to have to do. And what else are we doing back in our actual console version of this game? So we seed that. All of this stuff I can just skip for right now. We're not going to clear this screen. We're not going to be reading from buff.io. We're not going to print out these instructions. Here seems to be where most of the logic takes place. So it seems as though I'm going to have to, first of all, figure out what the computer did. So I can copy this and go back here and paste that in, because I know I'm going to have to roll the computer's value and see what that's going to be. And let's go back again and look some more at our code. If we look at this, do I need to do this part? If player choice equals rock? No, because I'm not going to get that as a string, so I can skip that. Let's keep going down. Aha. I definitely want this information. And I'm not going to use all of it, but I'm going to want that for sure. So let me go back here and paste that in and look at it. So logically speaking, I'm going to get some kind of parameter, whatever that may be. Probably it's what the player chose. So let's say that's going to be rock, paper, or scissors, but it's going to be in an integer value. So I'll call that player value. And that's going to be an int. I think that will be the only thing we need to pass this function. So on the web page, I click a button which has a value of, say, 0, 1, or 2 for rock, paper, and scissors, respectively. And then I pass that to this function. So I can now do the necessary work. Well, I know I want to return, say, what the computer chose. So let me create a variable up here. Say, computer choice. And that will be a string, and I'll initialize it to nothing. Here I don't want to format print line. Maybe I want to populate that value. Computer choice. Populate that variable. Will be equal to computer chose rock. That seems to make sense. So now let me copy this bit and replace it here, and replace it here, and get rid of these trailing parentheses that I don't need. Okay, that kind of makes sense. It really does. So now at this point, I will have the computer choice, which means I can return that. So I can say computer choice. But I also, of course, need to figure out who won. Well, how am I going to do that? Well, how do we do it before? Let's go find out. Down here, we say if player value equals computer value, it's a draw. This is where we figure out what's going on. So let me copy this. And we'll have to change it, but it's a good starting place. Let me come back here and paste it in right here. So we have, first of all, we're printing to the console here, and that really is the kind of information I want to print under the round result. So let's create another variable up here called round result and assign that an empty string. And down here, instead of saying it's a draw and trying to print it to the console, because we don't have a console, instead we have a web browser, we'll just populate that variable. Round result is equal to it's a draw. And we don't have to worry about this I, because we're not running in a loop, which means I can get rid of this comment. Now my second one is, else if player value is equal to -1. Well, again, we're not in a loop, so I can get rid of those lines entirely. And instead, we can say, if player value, where did I get that? As a parameter passed on line 14. If the player value is equal to computer value, this is our modulus work we did last time. So it seems to me that we don't need to worry about this at all. We can just say, round result equals player wins. And here we can say, round result equals computer wins. Now, is there anything else we need to do here? Because it seems as though we now have round result. We can send that back. Well, the last thing that I'm returning here, I decided I also wanted to return a numeric representation as to what took place in this game. So what I'm going to do is go back up to my constants and define those as constants. And I'll say player wins equals 1, computer wins equals 2, and draw equals 3. And those are totally arbitrary values. But now I have an easy way of representing my return value down here. So I can say, let's declare a variable called winner, and that will be an int assigned the value of 0. Okay? And down here, when it's a draw, I can just say winner equals draw, my constant. And here I can say winner equals player wins, right there. And you probably guessed this part, winner equals computer wins, my constant. And then I return winner. Okay, so we've got this built, and I know this will compile. There are no errors in here, but we're not doing anything with this yet. So if you think about it, this is a package, and we need to call it from our actual main package in play round. So what we need to figure out is, first of all, I know I want to call that function I just created, which is called play around. So I could do it like this. I could say winner, which I better spell right, and computer choice, and the third thing I'm returning is round result. Those are all assigned the value of RPS dot, and I'm looking for play around. And I'm passing it, it has to have an int. So I can just put a 1 in there now to make it compile. Then come down here and say log.println and print those variables out and say winner and computer choice and round result. I can actually make this do something by running it like this. Now this isn't hooked up to our web page yet, but it gives me a means of verifying that this is actually going to work. So what I can do is say go run main.go, and it starts, that's good, and go back to my web browser, and remember our URL for playing around is /play, so we'll go back to our web browser, and I'll just put /play at the end of this, and hit return. And I should get a blank screen, and I do, but if I go back and look at my log file, I have some values. 2, computer chose scissors, and computer wins. Let me run this again by refreshing the page. And I'll go back and look at my console, and it says this time 3, the computer chose paper, it's a draw. Okay, so this seems to be working. So it seems as though the next step is to figure out how to connect what's going on in the web browser with what's going on in the back end, our application, and to actually have that web page communicate with our back end in real time. And we'll get started on that in the next lecture. So we've implemented some of the logic from our rock, paper, scissors game in our web application. And I have it running right now, but I'm going to stop it and close my terminal window. So we have our main function, which has 2 roots that we're listening to, /play, which calls the handler play round. We're calling it from line 20. That's where we match the path that we're asking for in a web browser. And that would execute the function on line 14. And the same way, when we're displaying our home page, we get that handler call on line 21 in our main function. And that executes the function on line 10, homepage. So right now our homepage is just displaying HTML. And right now our play around function is just calling the play round function in our RPS package and populating 3 variables, winner, computer choice, and round result. And what we need is some way to get that information, those 3 pieces of data that we have on line 15, from our web application back to our web page so we can do something with it. And the problem is, it's not that easy to pass 3 discrete pieces of data like that. We could do it. We'd have to send the response 3 times. So we'd have to send the winner, then send computer choice, then send round result. But it's far more efficient to send all of the necessary information at once. And the way that's most commonly done in web applications is by using a format known as JSON. JSON. Some people pronounce it JSON. I call it JSON. And it stands for JavaScript Object Notation. Now I have an example of a JSON file right here. Let me bring it up. It's a really simple one. So as you can see, JSON begins and ends with curly braces. And each entry in a JSON file exists on its own line. And the name is on the left side with double quotes around it, and then a colon, and then the value is on the right side, followed by a comma, except for the last line. Now, this is a really simple JSON file. You can have far more complex ones that are nested, that are arrays, but we're just dealing with a really simple JSON file right now, and that's sufficient for our purposes today. So in this example, this JSON file has 3 pieces of data: ID, language, and strongly typed. And the first one is an integer, the second one is a string, and the third one is a Boolean that only takes true or false. So this would be a really useful way to send information from our web app back to our web page, but it does require some changes. So what I'm going to do is go back to my rps.go file, and instead of having this function play around, return an int, a string, and a string, I'm going to define a new type. And we already know how to do that. Type, and I'll call this one round, because that's what we're passing, is the information for a given round. And it's a struct. And I'm going to give it 3 members: winner, which will be an int. And I'm also going to give it computer choice, which will be a string, and round result, which will also be a string. And of course, these 3 values, or these 3 members of our struct round, our type round, correspond to the int, the string, and the string that we are returning from our play round. And in play round, rather than returning those 3 things, I'll just return one thing: type round. Which means I need to go to the very bottom of this function and do something else here. I need to create a new variable, which I'll call result, and it will be of type round. And I'll simply populate the members. So result.winner is equal to winner. Result.computerChoice is equal to computer choice. And result.roundResult is equal to round result. And I'll return that instead. Return result. Which means I can get rid of line 54. So now my function is returning my custom type round, which means back in main.go, instead of this line right here on line 15, instead of that populating 3 variables, I have to get rid of this, of course, and I'll just have this take the one thing being returned by play round. Now, what am I going to do with that? Well, it's a little difficult to simply return a struct result, for example, which is a struct of type round, or more accurately, type rps.round. I can't return that as JSON. But what I can do is convert that struct result of type rps round directly into JSON. And Go allows us to do that ever so easily. And we do it like this. I'm going to declare a variable called out. I'm going to check for an error, and that will be assigned the value of from a built-in package called JSON, which is built right into this standard library. And I'm going to call a function Marshall indent. And that takes 3 arguments. As you can see in the preview here, it takes the interface, which is any type. It'll take any kind of value that can be converted to JSON. Then it takes a prefix, which we'll ignore, and the number of spaces you want to indent it. So I want to take what I just got from rps.playRound, which is result. I'm going to ignore the second parameter just by passing it an empty string, and I'll indent everything that many spaces. Okay? I'll check for an error. If error is not equal to nil, then I'll just say log.println error and return, because I don't want to go any further. And I'll have an error message written to my log file. And now I can simply write that out, which is actually JSON now, directly to the browser. But remember that header set that we did a little while ago? I want to tell the browser that it's about to receive JSON. So once again, I'm going to use my response writer, and I'm going to call the header function, and I'm going to set that And this time, the content-type will not be text HTML. Instead, it will be the content type for JSON, which happens to be application.json. So I've set the header. Now I just go w.write out. Okay. So again, we're simply passing this our play around function the value of 1, but I should be able to start my application now, go to localhost :8080/play, and see what kind of result I get. So let's try that. Go run main.go. Everything compiled, that's encouraging. So let's switch to our web browser. And I'll simply click in my address bar. I have the correct URL in there. I'll hit return. And look what I get back. Now, my browser formats it nicely, but I can actually view the raw data by clicking here. And there you see, we have JSON. So we're getting winner set to 3, computer choice, computer chose paper, and round result, it's a draw. Now this is good, but I don't like the way that these are named, because you rarely see JSON files with this kind of naming conventions. Winner is usually lowercase. Computer choice would all be lowercase with an underscore between the two words. And the same thing with round result, which would be all lowercase with an underscore between round and result. And that's just kind of a convention. So I'm going to go back to my code, and I'm going to tell Go, whenever you render this kind of information, which is back in our rps.go, I'm going to stop the application and close this. At the very top, where I define this round type, I can actually add a little more information in here. And you do it using backticks, that surrounds everything, and you simply use the keyword JSON, and then in double quotes what you want this to be called when it's rendered to JSON. And I want it to be called winner, like that, because it looks better. And the same way, JSON, computer underscore choice. And finally, for round result, backticks, JSON, double quotes, round underscore result. And I'll save this to format it. And I will go back to my, what's this underlined for? Bad syntax for, oh, I'm missing a quote there. That's what it is. Try that again. Good thing I noticed that. Save this, and I'll start my application. Go run main.go. And go back to my web browser, and I'll reload this page. And now the names look ever so much better. Round result is formatted the way that I expect to see JSON formatted. Okay, and I can refresh this as many times as I want, and I should get different values every once in a while. Computer chose scissors, computer wins. Computer chose rock, player wins. So it seems to be working really well. Perfect. So now that we're actually returning JSON, and I'll stop this application right now. Now that we're actually returning JSON, we have a means of passing that information to our web browser, because web browsers, which have JavaScript built in, they can parse JavaScript object notation or JSON files. So I can pass the JSON file to my browser, have it parse that information, and then do something with it. And we'll get started on that in the next lecture. So now we have our web application sending JSON to our web page. Or actually, it has the potential to send information to our web page, but we haven't actually requested it yet. And in order to do that, we need to make some changes to our index.html file. So I have that file open in front of me, so open it up. And I'm going to open my terminal and start the application. Go run main.go. And I'm just starting the application so that I have a means of making changes to my HTML and seeing that reflected in my web browser. So I'll go to my web browser and reload this page and just make sure it's visible. And it is, and everything works. Okay, so I have that page available to me now. So let's go back to our Visual Studio Code and make some changes to this. Now we're going to use a programming language called JavaScript, which is built into every major modern web browser. And it's been around for a long time. So you may be familiar with JavaScript, and this will be really easy for you, but if not, it's not that hard. So the first thing I'll do is I'll go to the very bottom of my index.html file, and between the closing body tag and the closing HTML tag, I'm going to write this, script. And this is an HTML tag that says everything between the opening and closing script tag is a script of some kind. And in the vast majority of cases, it will be JavaScript. And I'm going to define a function that will allow me to click on one of these buttons. Let me go back to my web browser. We'll just do the rock button for right now. When I click on rock, I want one of the paragraphs up here to change, to show different content. So, as you might imagine, when we're finished, clicking on rock will actually send a request off to our web application saying, hey, the user clicked rock. The web application will do its magic using the RPS package and the main package and send back JSON, which we can then consume, parse, and make whatever changes are necessary on our web page. But right now, let's just get started changing content just using JavaScript. And we'll get talking to our web application in a lesson or two. So back to my code. In here, inside the script tag, I'm going to create a function. Now in Go, you create a function with this keyword. But in JavaScript, you use the function keyword, fully spelled out. And I'm going to call my function choose. And it's going to take one parameter, which I'll just call x. Now in Go, again, you have to put the type after the parameter declaration in a function. But in JavaScript, you do not. It is not a strongly typed language. So I can just put x. And this function does not return anything. So I'll just have an opening and closing curly braces. And what I want to do this time around, when I click the rock button, and that exists on line 25 in our HTML, I want to change the contents of the paragraph tag on line 16, which is called player choice. So that means I need to get access to that particular paragraph. And I do so using its ID, which is player choice. So the way you get a reference to that is you use the keyword document, which refers to the entire web page. And now I want to get an element by ID, like that. So get element by ID. And make sure you get the case right, or this will not work. And it takes one parameter, just the ID of what I want to get a reference to. In my case, it's player choice. And a dot, I want to change the HTML, the inner HTML of that paragraph. So it's inner HTML. I'm going to change that to you clicked rock. Not fork, rock. And in JavaScript, lines end with a semicolon. Okay? You don't have to. It'll work without it. But you should. It's good practice. So I'm going to save this. And I'm going to go back to my web browser. And I've defined this function. And when I click on this, nothing happens. I'll refresh the page to make sure it's current. Nothing happens, even though I've written that function. So if we go back to our code, you can imagine why it's not happening. It's because I've defined this function, but at no point is that function called. So on line 25, I want to make the rock button execute that function choose and pass it some value whenever somebody clicks on it. And we do that with a simple attribute, onClick. And that's equal to, in double quotes, you can use single quotes, but I always use double quotes, choose, and give it some value. And I'll pass it 1, okay? Actually, I'll pass it 0. Why not 0? So I've called the function choose anytime the user clicks on this button. And I'm passing it the value of 0. And we're not doing anything with the 0, but we will be before too long. So let's save this, go back to our web browser, reload this page, and you need to reload or it won't work, and I'm going to click rock. And there, you clicked rock. Now clicking paper does nothing, clicking scissors does nothing, but clicking rock again actually does. Believe it or not, even though you won't see any changes, when I click on this, it actually repopulates this with you clicked rock again. So that, in a nutshell, is how we execute JavaScript. Now, clearly, I want to do more than just change the text to you clicked rock, you clicked paper, whatever it is, but I need to make a decision in here. And the decision can be something as simple as this. If x equals, we're in JavaScript. You need to put the what follows the if statement in parentheses. If x equals 1, then do something. So we'll just do it like this. And we'll say else if x equals 2, do something. And up here I'll make this a 0 because that's what I'm passing it, 0. And I'll make this 1. Else, do something else. So what I can do is something as simple as this. Take this out of here, cut it, and whenever somebody passes or clicks rock, I'm going to get a 0. So if x equals 0, I'll paste this in here. Otherwise, if they clicked 1, I'll say it, you clicked paper. And I'll paste it in here for the third one. The third situation is you clicked scissors. And up here on paper, I'm going to again have an onClick attribute. OnClick equals choose, but this time I'll pass the parameter of 1. And for scissors, I'll have onClick equals choose, and I'll pass it 2. So if I save this and go back to my web browser and reload this page, now when I click rock, it should say you clicked rock. And when I click paper, it should say you click paper. And when I click scissors, it should say you click scissors. Okay? So there is an easy means of changing the content on a web page with JavaScript. And the nice thing about this is we're never leaving this web page. At no point does this web page reload unless I manually reload it. It's all done using JavaScript. So our next step is to come back here to our code and somehow make this function choose actually call our web application and get some JSON back and then do something with it. And we'll get started on that in the next lecture. So we have JavaScript working to change the content of one paragraph on our web page. And the next step is to actually call our web application. Now, I'm still looking at index.html, and I still have my web application running. And I'm going to make some changes to the choose function. And I'm going to first of all just call our web application and request a response, which will come in the form of JSON. And I'll just print that to the console, the JavaScript console. And if you haven't seen that, don't worry, you'll see it in a moment. So I'll do that right here on line 32. And I'll do it right after I declare the function choose. So what I'm going to use is one of the built-in functions that's available to us from JavaScript called fetch. And fetch actually makes a request, just like a web browser. It makes a request to some URL or some web address and gets a response, but it does it behind the scenes without leaving the current web page. And that's exactly what I want. I don't want to reload the page every single time the user makes a request or clicks a button. Instead, I want to go get the necessary information and then use JavaScript to change the contents of the page without ever leaving it. So if you'll recall, the URL we're going to in our web application is /play. But I'm going to add a little bit to that. I'm going to say play question mark and then C equals, and then I'll append the value of X to that. Now X is the parameter passed to us when we call this function, and the question mark is just a URL parameter. It's passing some extra information along with the request for whatever /play returns. So if I clicked 1, for example, if I click paper, then I would be going to the URL, whatever my host name is, /play question mark C equals 1. So that's the first part of the request. Then I'm just going to go to the next line because the fetch statement is not finished yet. So after that has happened, after we've made that request, then, which is a keyword available to us, we're going to get a response in some format. Then we type =greater. Response is going to be converted to response.json. In other words, parse the JSON response. Get it into something that I can use in JavaScript. So that happens next. Then on the next line, then again. And what I can do here is get whatever I get from the previous then, which I'll just call data. And that's going to go to, again, we use the =greater notation. And then I'm going to use curly braces. And inside of this, I'm just going to say console.log data. Okay? So all this is doing is fetching /play question mark C equals whatever the X value is, getting the response, converting it into a format that we can read, so from JSON to something JavaScript can read, and then we're just writing the result to the console. So let's run this application and see what happens. So it's already running for me, and if it's not, you need to start your application. Then go to your web browser. I'm going to reload the page to make sure everything is current. Then I'm going to go to the top right-hand corner and find where the JavaScript console is. Web Developer Tools. There. Okay, so this is actually going to watch the console. And when I did that console.log, whatever that prints will show up over here, not in the actual main browser window. So I'll click rock. and it gave me something back. So here I see, and I'm using Firefox, it'll look a little bit different in Chrome if you're using Chrome, but you'll get the same basic information. We get the computer choice, computer chose paper, round result, it's a draw, and winner is 3. So we're actually successfully requesting information from our remote application, getting the results as JSON, and now we just need to do something with that JSON and change the content of our web page. And we'll take care of that in the next lecture. So we're getting very close to having a functional web application. And in our JavaScript section at the bottom of index.html, on line 32, you'll see that we're calling /play $C equals, and then whatever the user clicked. So in other words, if they clicked the rock button, that X would be equal to 0, but if they clicked scissors, the X would be equal to 2. But back in our main package, at line 15, the play round function, this handler, is what's called when we use our fetch request in the JavaScript back in index.html. And we're actually not doing anything with that query parameter. We're actually hard-coding a 1. So no matter what button the user clicks, at the moment, we'll be accepting only the value of 1. So they're always going to be choosing paper, and that's no good. So we need to fix that. So how do we get the value of C? Back in our index.html, we have $C equals, and then whatever X is. So we need to get that C parameter, figure out what its value is, and that will be X, and do something with it. Well, that's pretty easy in Go. Back in our main function, our main.go file, under the playaround function, I simply kind of put a line in here and say player choice, which is a variable I'm declaring, comma, and then an underscore, because I'm going to disregard the second return parameter, is assign the value of, and we'll use our strconf package, which we've used before to convert a string into an integer, and that is a to I. And the string we want to get is actually pulled out of the R variable, the request variable that we have right up here. So it's R dot, and the syntax is URL, whatever the URL is, query, which says pay attention to the query parameters, dot get, and we're going to get C, because that's what we called it in our query parameters. So now we have a player choice. So instead of hard-coding this 1, I just changed that to player choice, and now we have an actual game where the player chooses an actual value. They're not always getting paper. So that's our first thing. Now back in our index.html, I actually want to change it. So I'm not just logging the data here. So I'm just going to comment this out. All of this logic right here belongs inside of this, because we don't want to do anything to the page until we actually get the response from our remote server, from our web application. So I'm going to paste that in here, and I'll format it a bit. There. And what else do we want to do? Well, first of all, let's say not you clicked rock. We'll say player chose. And I'll make rock in all caps. And then I'll just copy this and paste it here and make this paper and paste it here and make that scissors. So it's closer to what we had in our console application. Now there are two other things I want to change. If you recall, back on line 17, we have the computer choice. We need to change that to whatever we get back from our JSON. And round result, we need to change that to whatever we got back from our JSON. And again, we use exactly the same syntax we do in our if statement here on line 36. We use document.getElementById. And this time I want computer choice dot inner HTML is equal to, and I can't hard code this. Instead, I just get it from my data variable. So data, which we have from line 34, and we just say computer underscore choice. Now that computer underscore choice, where does that come from? Well, that's from the JSON file. So back in our rps.go, at the very top, I defined the value, the member computer choice, which is a string. I said in JSON, call that computer underscore choice. So that's where computer underscore choice comes from. So back in index.html, I'm just going to duplicate this line. And now I want the paragraph with the ID of round_result. And here, it's round_result. So I'm going to open my terminal. And do I have my application running? I do. So let me stop that and start it again. You need to restart the application, otherwise the changes we made in our main package will not be reflected. I'll start it up. Go back to my terminal or my browser. I'll refresh this page to make sure everything's current. I'm going to leave my JavaScript console open in case there's an error if I have a typo somewhere. So I'll clear it out and I'll say rock. Player chose rock, computer chose rock. It's a draw. So far, so good. Let's see if we get something different if I click paper. Player chose paper, computer chose rock, player wins. It seems as though this is working perfectly. Now, the last thing I'll do, just because it's cosmetic, is I'm going to make a slight change to this line right here. It's a draw. I'm going to change the formatting, just because I can. So I'll go back to my IDE. I'll open index.html, and I'll find the part where that's printing out. And I'm going to add a bootstrap class to this. Class equals text-danger, just to make it look a different color. And I'll go back to my web browser, reload this page, and away we go. I'll play rock. Now it's in red. That looks better. Okay, so there you go. Now we have a fully functional, very simple, but fully functional web application. So hopefully you found this useful and interesting, and it gives you some indication as to the kinds of things you can do using Go. Go is extremely good for web applications, both for back-end REST APIs, as they're called, and also for fully functional web applications that actually generate pages of HTML and send them to the end user. So there you go. Let's move on. So we have a fully functional web application now, but you might have noticed something in the code, and that is in our rps.go file. I have these constants, player wins, computer wins, and draw. And in the type for the round, we also have this winner, and that's an integer. And of course, we're populating that with the constants here, down a little bit further in our code. So if we go down here, we say on line 45, winner equals draw, 48, winner equals players win, and 51, winner equals computer wins. So those are integers, and they're being passed back as part of our type, and then they're being encoded into the JSON, but we're never using them. And I left them in there because I want to give you a challenge. I've modified the code, and I'll show it to you in the next lecture, but let me go over to my web browser and reload this page to make sure it's current. And I've made a slight change, and I want you to do this change as a kind of challenge. So now, when I click on rock, I have my player chose rock, computer chose rock, it's a draw, and then we have a little message here, great minds think alike. And if I choose paper, it's a draw again, but I get a different message. Uh-oh, try again. So I got the draw both times, but I get a different message both times. And now if I choose the third one, again it's a draw. Nobody wins, but you can try again. So let's try one to see if we can get a win or a loss. Draw. There. Player wins. You should buy a lottery ticket. I'm going to try to find the computer wins. Computer wins. Too bad. This is a change I want you to make. Now, I'll give you some hints. So to go back to our code, up here, we're not going to need these constants anymore. We're going to have to change winner, at least change its type, but probably change its name as well to something more meaningful where you can store the message. And down here, a little bit further on, here is where you're going to populate that message. So what I would do is create 3 data structures, one for a win, one for a loss, and one for a draw, and populate those with the same number in each one. You might use a map, you might use a slice, whatever you think is going to work for you. But make sure that all 3 have exactly the same number of entries. And then you'll generate a random number and pick from the appropriate data structure, whichever variable you have. One, you might call one win list and one lose list and one draw list, or whatever you want to. But choose a random entry from the appropriate variable and store that in a variable, And down here, instead of populating on line 55 result.winner, you might have result.message and store your text in there. It'll be a string. And then, of course, back in index.html, you're going to have to make some changes both to this section. You need to have a place to display that message. And down here, you're also going to have to make a change to this section, an addition that allows you to populate the place on your web page where you want the message to display. So, it's not too hard a challenge, but it will take you a little while. Give it a shot, and in the next lecture, we'll go through how I solved this problem. Good luck. So how did you make out with the challenge? Hopefully you didn't find it terribly difficult, but it might have taken you a little while. So let's go through how I completed these changes. So to start with, let's look at our rps.go package, because that's where the majority of the changes take place. So as I did last time, everywhere I have a change, I have a comment with 3 leading asterisks, just so it's easier to find. And you can find these in the course resources for this page. Download the source, you'll see all of these comments. So I commented out lines 13, 14, and 15, which you can actually delete, but I'd left them there to show you what change I would have made. In the same way, I changed the type round and changed the first member from an int named winner to a string named message, and gave it the third parameter, which tells Go to name it message with a lowercase m in the JSON it produces. A little bit further down, I created 3 slices of strings, and you might have used maps, but strings work or maps work, it's entirely up to you. So I created 3 slices of strings, each with exactly 3 entries. One for when the player wins, one for when the computer wins, and one for when it's a draw. Then, a little bit further down, on line 51 in the play round function, we're not using the winner variable anymore, so there's no need to have an int named winner initialized to 0. So that's pretty straightforward. And down here, just after the switch statement on line 53 in the revised code, I generate a random number, which I don't need an F after, so let me delete that, from 0 to 2. Of course, that's because, as you know, we start counting at 0 in slices. So that gives us a number from 0 to 2, or one of 3 possible numbers. And we use that random number to pick a random message. And then I declare on line 69 a variable named message of type string with its default value of an empty string. Then, in the if statement, where we begin on line 71 in the revised code, instead of saying winner equals draw, well, we don't have winner anymore, and we also don't have the constant draw anymore, so that can be deleted. I commented it out just so you can see what used to be there. And then instead, we take our string variable message, and we give it a value from the slice of strings called draw messages. So we'll have a random message stored in there, but they only come from the variable called draw messages. So one of 3 possible responses. And I do exactly the same thing in the next 2 clauses of the if statement. So the middle one, we choose it from win messages. The bottom one, we choose it from lose messages. And the only other change in this code is at the very end. Instead of populating result.winner, we populate result.message, because result.winner doesn't exist anymore. So hopefully you got that part right. And in the index.html, that's the only other place where we have changes. Now, comments in HTML are like you see here on line 19. It begins with a less than symbol, an exclamation mark, then 2 dashes. And you close the comment with dash dash greater than sign. So again, I put comments in where the changes took place. So I added a paragraph, and I gave it the class of text success just to give it green text. But if you didn't do that, don't worry about it. And I gave it the ID of round_message. So I have a place to put my content, and it defaults to a non-breaking space. And then if I go down to the JavaScript, the only other change I needed to make here was to add 1 line. To grab the value from data.message, which is in the JSON that's passed to this, and use it to change the value of the element with the ID of round_message. And hopefully you didn't have too much trouble with this. But if you did, feel free to download the source from this lecture and compare what I did with what you did. And finally, if you had a slightly different approach but came up with the same end result, that's absolutely fine. All right, that's it for this section. I had a great time. I hope you did as well. Take care.